Chicos y chicas, al directo del NVIDIA GTC 2025. Me ha asustado, he visto aparecer a Jensen por la pantalla y digo, madre mía, que esto empieza ya. Bienvenidos a este directo donde vamos a estar cubriendo, directo patrocinado, el evento, el GTC de NVIDIA, el evento anual que celebran, donde traen todas las novedades que quieren contarnos relacionadas con inteligencia artificial, con robótica, con semiconductores, con gráficos acelerados por ordenador, por todo lo que NVIDIA toca, que es muchísimo. Y que además justo en el día de hoy, sabemos que este es un evento que dura toda la semana, del lunes al jueves, pero hoy es donde tenemos la keynote principal, donde va a salir el CEO, va a salir Jensen, y nos va a hacer pues una sesión de 1 hora, 2 horas, contándonos todas las novedades. ¿Y va a haber alguna novedad? He estado mirando rumores, ahora comentaremos qué pueden sacar, pero creo que va a ser una jornada interesante y como siempre es un evento que mola porque nos permite también tomar un poco el pulso a la industria en general, porque sabemos que NVIDIA es una empresa que está tan bien posicionada en toda esta revolución de la IA, que bueno, que al final de una forma u otra, ver una charla de NVIDIA tiene que ver con ver un poco cómo está el estado de la situación de la IA. Entonces, creo que va a ser una tarde interesante, una tarde divertida, y para empezar necesito que me confirméis que a mí se me escucha bien, que me estáis escuchando bien, para que cuando empiece la keynote pues podamos seguirla a gusto. Tengo abierto aquí el enlace en YouTube de lo que va a ser el GTC y estaba fijándome que se oye raro, ¿vale? Voy a subir el volumen para que lo escuchéis, pero se oye como entrecortado, ¿vale? Y no creo que sea algo del propio streaming mío de cómo se ve YouTube, porque si cogemos un vídeo cualquiera, vamos a coger de este chico maravilloso.
Google has just revolutionized.
¿Por qué salgo en inglés? Madre mía. Esto si os pasa, que sé que algunos se han quejado, es porque YouTube ahora automáticamente traduce los vídeos al inglés y en algunos casos, si tenéis el canal configurado en inglés, como me suele pasar a mí, te salta la versión en inglés. Google acaba de revolucionar la generación de imágenes con inteligencia artificial. Y sé ¿vale? Entonces, si se está escuchando bien por aquí, es cosa del streaming de NVIDIA. Espero que se den cuenta y lo arreglen antes de empezar, porque si no, pues vamos a tener que verlo desde el propio portal de NVIDIA, que tampoco es problema, pero vaya faena para ellos que están haciendo directo. Pero bueno, a nosotros no nos va a impedir disfrutar, porque por suerte tenemos alternativas para poder verlo. Y simplemente recordaros cositas importantes relacionadas con el GTC. Ya sabéis que el GTC es un evento que dura toda la semana. A pesar de que hoy es la keynote principal, desde ayer tenéis contenidos a los que podéis asistir de forma gratuita. Esto es una cosa que cambió desde que ocurrió la pandemia, y es que antes este evento, el GTC, era un evento privado. Tenías que pagar la entrada si querías ver los contenidos. Cuando llega la pandemia, se tienen que convertir por necesidad en un evento online, y al hacerlo online, pues lo abrieron a todo el mundo. Y esto lo han mantenido, y eso está muy guay porque nos permite, registrándonos gratis, poder acceder a un montón de charlas que están relacionadas de una forma u otra con la industria de la IA o con las diferentes industrias con las que NVIDIA trabaja. Entonces, si os registráis al GTC en la página web, vais a ver que tenéis un montón de sesiones a las que podéis asistir. Todas estas son gratuitas y tenéis tanto a nivel técnico, ¿vale? Algunas que son más técnicas, algunas que son más de negocio. Tenéis un montón donde elegir, sesiones de durante todos los días, de un montón de industrias diferentes, así que echadle un vistazo. El registro gratuito, pero es que además, como parte de la promoción que estamos haciendo junto a NVIDIA, hemos preparado un sorteo, como hacemos habitualmente, donde entre otros grandes premios estamos sorteando una RTX 5090. Creo que seremos de los pocos que tengamos acceso a una 5090 porque ya sabéis que están agotadísimas por todos lados, y de hecho fue la propia NVIDIA la que me dijo, ojo Carlos, que a lo mejor no podemos ni siquiera darte una para sortear porque estamos sin stock, pero al final la hemos conseguido. Y es una GPU RTX 5090 firmada por el propio Jensen Huang, ¿vale? El CEO de la compañía se sentó una tarde y dijo, a ver, para los fans de .csv vamos a firmar la GPU y la vamos a sortear, ¿vale? Aviso, Este sorteo tiene restricciones geográficas y esto es una movida, yo sé que no es lo ideal, yo me hubiera encantado hacerlo de una forma diferente, pero no todos los países de los que vosotros me veis podéis participar para ganar la GPU. Por restricciones de envíos que están relacionadas por temas políticos, ya sabéis que, y hoy seguramente lo hablemos en el directo, que una de las cosas que están sucediendo a nivel geopolítico es la limitación de envío de GPUs a determinados países. Y aquí no podemos hacer más que ajustarnos a estas restricciones. Con lo cual, yo hablé con NVIDIA y les dije, necesito al menos una alternativa y lo mejor que hemos podido conseguir son créditos para los cursos de Deep Learning que ellos tienen disponibles. En total, 10 créditos por valor cada uno de 90 euros. En total, unos 900 euros de premio, que está bastante bien para aquellos países que no puedan participar por el sorteo de la GPU. Que me sabe fatal porque ya sabéis que el resto de años hemos conseguido hacerlo abierto a todos y enviarlo a donde haga falta. Este año no ha podido ser así. Yo lo he intentado pelear, pero hay cosas con las que no puedo hacer nada. Entonces, este sorteo está disponible para todos, porque si no es una GPU, son los créditos para los cursos de NVIDIA. Y todos los datos de cómo participar lo tenéis abajo en la cajita de descripción. Tendréis, es un hilo en Twitter y ahí tenéis todos los pasos que son muy sencillos. ¿Cuáles son? Os lo digo para que lo hagamos bien. Registraros a través de mi link. Hay un link y os registráis al GTC si todavía no lo habéis hecho a través de mi link. Paso 1. Paso 2. Tenéis que hacer retweet a ese hilo, ¿vale? Para generar el efecto viral. Paso 3. Ver una de las sesiones que no sea la keynote principal. La keynote la vamos a ver entre nosotros, eso no os preocupéis, pero alguna de las sesiones, pues yo qué sé, oye, que quiero ver una charla entre Bill Daly y Jan LeCun, guay, súper interesante, mola un montón, pues os la veis y con eso ya NVIDIA sabrá que vuestra cuenta registrada con mi enlace ha visto una de las ponencias. Y aún así hay un cuarto paso, que es que en ese hilo hay un formulario donde tenéis que completar cuál es vuestro usuario, qué charla habéis visto durante la semana y ya está. Y con eso ya juntáis las 4 bolas de dragón y ya entráis a participar en el sorteo. Tan sencillo como eso y es una forma de asegurarnos de que os registréis, pero también disfrutéis y paséis un poco por el GTC virtualmente y disfrutéis de alguna de estas charlas, ¿vale? Creo que ha quedado meridianamente claro, hemos tocado los palos que teníamos que tocar. Si tenéis alguna pregunta en el chat, preguntadme, ¿vale? No es tan complicado. Hay alguien que dice sencillo entre comillas. No es tan complicado, ¿vale? No sé, estamos sorteando una GPU, tampoco es que estemos regalando una camiseta o una fantástica taza de NVIDIA para acelerar tus mañanas. Bueno, dicho esto... os recomiendo bastante, a mí el GTC es una conferencia que me gusta mucho patrocinar porque realmente me gusta mucho lo que se puede sacar de ella y otros años lo hemos hecho de hacer sesiones cuando hacíamos Twitch sobre todo, que daba más pie a hacer locuras en directo, donde nos poníamos a elegir ponencias y nos metíamos y veíamos qué nos ofrecían y tal y se sacan cosas chulas de aquí, ¿eh? Se sacan cosas muy chulas. Hay un montón de temas diferentes. Si os gustan gráficos por ordenador acelerados, si os gusta Nerf, si os gusta Gaussian Splatting, si os gusta generación de vídeo, hay un montón de temas. Y me da pena, por una parte, el no haber ido este año en presencial. Justamente hace un año, en marzo del año pasado, estuve por ahí. Estuve en el GTC viendo en directo a Jensen y este año NVIDIA me lo ofreció de nuevo. Me dijo, Carlos, ¿te quieres venir a San Francisco? Pero claro, hace 2-3 meses que estuve ya por ahí, por San Francisco. Ya sabéis que estuve unos 3 meses por California. Y volver a coger un avión ahora mismo se me hacía un poco... que me daba bola, se me hacía bola. Pero ahora es lo típico que dices en su momento, nada, coger un vuelo, tal, qué pereza. Pero hoy lo pienso y digo, podría haber estado ahí, con lo chulo que estuvo. Y creo que nunca llegué a hablar de mi experiencia por allí el año pasado, cuando fui al GTC. Pero fue un evento bastante chulo. Yo he de decir que me esperaba lo que era en el recinto, un evento más grande todavía, muy a la americana. Y ciertamente era un evento grande, pero equivalente a lo que aquí se hace también, pues por ejemplo, el Mobile World Congress y cosas así. De hecho, el Mobile es bastante más grande. Al final es un evento que reúne a muchas empresas muy grandes. En este caso, NVIDIA pues es solamente una empresa. Pero ciertamente es un evento que impresiona por todas las marcas que ves allí colaborando. Puedes ver la tecnología punta, puedes ver el año pasado vimos las Blackwells, ¿no? Que eran la arquitectura nueva que sacaron. Ves un montón de ejemplos de robótica. Hoy se hablará mucho de robótica en el GTC seguramente. Siempre Jensen le gusta el tema de la robótica. El año pasado me acuerdo que fue bastante impresionante que de repente en el escenario salieron los robotitos estos de Disney, que son los robots que están como hechos muy como si fuera un personaje de Pixar, ¿no? Que caminan y son súper graciosos. Y salieron al escenario, pero que luego mostraron con la pantalla gigante como todos los robots humanoides que estaban disponibles en por aquel entonces, hace un año. Y yo creo que si este año tuvieran que volver a hacer esa puesta en escena, es que le faltaría pantalla porque hay tantos robots humanoides. O sea, han salido tantas empresas de robots humanoides en el último año que me parece una locura. Me parece una locura. Entonces, bueno, cositas interesantes para hoy que podamos ver. Pues se rumoreaba una nueva actualización de la arquitectura Blackwell, ¿vale? Estaban hablando del Blackwell Ultra, lo cual me sorprende porque al final no deja de ser una arquitectura que el año pasado se presentó. Entonces ya ver una iteración que mejore, ¿no? Lo del año pasado me sorprendería, pero es uno de los rumores que hay. Seguramente nos hablen de ¿cómo se llama el dispositivo este? El Digits, ¿vale? El dispositivo este pensado para ejecutar inferencia de modelos, de grandes modelos que puedes tener en el escritorio. Seguramente nos hablen de los NIMs, que es la forma de ejecutar inteligencia artificial de forma, ¿cómo llamarle? Como de forma estanca, ¿no? Como si fuera un Docker, pero en este caso para modelos de inteligencia artificial. Seguramente nos hablen de Omniverse, que siempre está ahí, sobrevolando como una entidad, una cosa que NVIDIA tiene, pero que no terminamos de concretarlo en cosas reales. No sé si nos hablarán también de la familia de Jetsons. Tengo curiosidad por ver qué presentan y sobre todo por cómo presentan al estado actual de la inteligencia artificial. Recordemos además el contexto que estamos viviendo actualmente, donde desde enero, de hecho tengo hasta la curiosidad. Vamos a hacer una apuesta, chat. ¿Creéis que se va a mencionar la palabra DeepSeek en el escenario? ¿Se dirá DeepSeek en algún momento? Porque NVIDIA no debería de tenerle miedo a DeepSeek. DeepSeek es una cosa que la debería favorecer, pero el relato que se instaló desde enero es que DeepSeek era algo que tenía que afectar de una forma u otra a NVIDIA, ¿no? Me decís, no, ni de broma, no, lo dudo. Pero realmente no tiene sentido, ¿eh? Y esto lo dije yo en el vídeo que hice de DeepSeek en el canal de .csv Lab. Es un modelo más y todos los modelos que vengan, por muy eficientes que sean de ejecutar, le favorece a la empresa que te está vendiendo computación y todavía tenemos grandes necesidades de computación. Aún así, se creó este relato, entonces no sé, tengo curiosidad. Si dicen DeepSeek, tengo que jugarme algo, no sé. Iba a decir me rapo, pero claro. Me corto una ceja, ¿te imaginas? No estoy tan loco. Bueno, vamos a ver si esto está arreglado. Pues parece que no. Entonces dejadme que... a ver si desde aquí lo podemos lanzar. No, este no era, perdón. A ver, vamos a ver si nos dejan entrar a través de aquí. Vale, a malas lo veremos desde este punto. Vale, voy a dejar la música muteada porque no sé hasta qué punto tiene copyright o no. Pero bueno, lo que os decía, el tema de DeepSeek se sobredimensionó demasiado y se entendió como que ya las necesidades de computación de la inteligencia artificial no iba a ser necesario y que por tanto se perjudicaba a NVIDIA. Pero no lo termino de comprar y no lo termino de entender. Muchos lo habéis comprobado, hay mucha gente que usa DeepSeek, que le gusta como modelo. Cuando entráis a la página web de DeepSeek, suerte que no esté caído, ¿vale? Tienen problemas de carga de usuarios y por tanto tienen problemas de falta de computación. Es una realidad. Cada vez que entráis a Runway, a Luma, a Sora, a BO2, a cualquiera de estos modelos, el tiempo que os esperáis, ¿vale? El tiempo que estáis esperando es una evidencia más de que todavía hay mucho margen de mejora en las necesidades de proveer computación. Es decir, mientras NVIDIA siga mejorando el hardware para ofrecer siempre estos modelos cada vez más rápido, siempre va a haber un mercado que le interese ofrecer estos modelos más rápidos. Y una base de usuarios que mientras... claro, esto no, obviamente tiene que escalar de forma que el precio sea justificable, si no, el usuario no va a pagar más por un poquito más rápido. Pero si en el tiempo NVIDIA consigue seguir mejorando sus procesos para hacer GPUs cada vez más baratas y con más oferta de computación, pues ya le está generando una necesidad a las empresas de decir, vale, pues actualizo mi clúster de Blackwells por la Blackwells Ultra o por la próxima arquitectura, la Rubin, que vayan a sacar. Eso siempre va a seguir estando ahí, ¿vale? Entonces, estamos en un punto raro, estamos en un punto además que los mercados pues tumbaron el precio de NVIDIA, bajó de 140 a 120 el precio de mercado. Luego ya con todo el tema geopolítico de Estados Unidos y todo el tema de los aranceles y todo esto, todo el Nasdaq se ha ido para abajo y el S&P 500 y la acción de NVIDIA hoy creo que estaban en 116. Ya eso no tiene que ver tanto con el efecto de DeepSeek. De hecho, el efecto DeepSeek se revirtió en el mercado. Estaba casi a punto de rozar de nuevo el máximo absoluto antes de empezar a caer toda la bolsa. Entonces yo ya os digo, y es la tesis que defendí en el vídeo, que el efecto DeepSeek no fue tan grave para NVIDIA como se planteó en general, con este miedo general. Todo esto lo digo para justificar que yo sí creo que se va a decir la palabra DeepSeek en el escenario hoy. Porque es una forma de reconocer que no le tienes miedo, ¿vale? Que no es un problema para ti. DeepSeek es un problema para empresas como OpenAI, para empresas como Anthropic, pero para NVIDIA, por ahora no. Para NVIDIA un problema sería que aparecieran empresas que hacen chips, que hagan hardware y que fueran lo suficientemente competitivas como para ponerle, bueno, para empezar a comerle un poco el mercado. Pero no parece que por ahora haya una empresa que cumpla esas características. No pueden nombrar competencia por regla, pero es que no es competencia DeepSeek. O sea, DeepSeek es un laboratorio. DeepSeek compra NVIDIA, ¿vale? Es decir, o sea, es que al final toda esta locura que se generó con DeepSeek, o sea, una de las informaciones que todo el mundo sabíamos es que DeepSeek, para poder entrenar a su modelo, compraron tarjetas, compraron tarjetas de NVIDIA. Entonces ya está, es que no es competencia, es un cliente. De hecho, a mí me preocupó en aquel momento el que, bueno, de qué forma había conseguido DeepSeek acceder a estas tarjetas, ¿vale? Porque técnicamente, por las restricciones de envío de GPUs, no deberían de estar vendiéndole a empresas chinas y de alguna forma esas tarjetas llegaron. La cosa es si fue con el favor de NVIDIA, ¿no? A través de ventas en mercados negros y cosas así. Bueno, líos geopolíticos. Qué cosas, ¿eh? Libre mercado le llaman, bueno, sí. Vale, voy controlando que no haya empezado y que nos lo estemos perdiendo. No, estamos igual. Fijaos, esto que estamos viendo aquí, si no me equivoco, creo que podría ser como una especie de diagrama de las oficinas de NVIDIA por arriba. Podría ser, porque las oficinas de NVIDIA son muy así, con el tema de los triangulitos y todo. Pero bueno, parece una ciudad también, porque tiene como carreteras y cositas por aquí. Bueno, os estoy leyendo en el chat, ¿eh? Tened en cuenta que NVIDIA no se considera una empresa de hardware, sino de software. Sí se debe ver afectada de algún modo por estos nuevos modelos. NVIDIA es una empresa de hardware. NVIDIA vende hardware y su mayor fuente de ingresos, o sea, déjame que lo mire bien, porque la gráfica es que es impresionante cuando la ves, pero NVIDIA gana por su venta de hardware a grandes empresas, a centros de computación y poco más. NVIDIA Revenue. A ver, déjame que lo miro. O sea, a ver si lo podemos ver por aquí. Esto no sé de qué año es, no sé si corresponde con este año. Sí, mira, el Q3 de 2025, ¿no? Pues todo lo verde, la barrita verde, es venta de hardware a data centers. Punto, ¿vale? Que aquí la gente dice, joder, es que tiene descuidado el mercado gaming. Bueno, es que, a ver, normal, ¿vale? Normal. Nada, es que va todo a data centers. Tengo curiosidad también porque ver qué más presentan, porque ciertamente este año parte de los anuncios se fueron al CES, ¿vale? Al evento este que se hace en Las Vegas a principios de año, que ahí fue donde NVIDIA presentó las 5090 y la serie 5000, que es lo típico que hubieran anunciado en su propio GTC. Y está bastante cerca, entonces ahí parte de los anuncios se fueron este año. Tu canal me da ansiedad. Quiero, pero no puedo verlo. Ojo, ya me sabe mal. Boneco. Ya me sabe mal. Estáis hablando mucho en el chat sobre el Project Digits. Y me parece muy interesante el Project Digits, la verdad. Y creo que si todo sale bien, estoy hablando con NVIDIA porque todavía no hay acceso a las Digits, pero puede que me consigan una para testearla y traer mis impresiones aquí en el canal, ¿vale? Entonces, en ese sentido, tened claro que vamos a tener información por aquí. Y nada, respecto al streaming, voy a intentar, en la medida de lo posible, ir analizando un poco lo que hablan. Seguramente si tenga que parar, pararé, porque al final la gracia de que estemos conectados todos es para un poquito charlar sobre lo que presentan. Pero tampoco voy a estar haciendo un doblaje en tiempo real de todo lo que diga Jensen, ¿vale? Esto vamos a intentar que sea agradable. Yo solamente espero que haya, por fin, pido, subtitulado automático. Sea como sea, esto parece que empieza ya, chicos. Entonces, dejadme que lo prepare todo. Vamos a ver si lo puedo poner como... Vale, si esto lo pongo así, se os corta la mitad y yo pierdo el chat. Vale, dejadme que haga un momento aquí un apaño rápido. Vale, si esto lo pongo así, ¿qué tal lo veis?
This is how intelligence is made. A new kind of factory, generator of tokens, the building blocks of AI. Tokens have opened a new frontier.
Han empezado con tokens numéricos.
The first step into an extraordinary world, where endless possibilities are born. Tokens transform images into scientific data, charting alien atmospheres.
Que siempre consiguen que al principio piel de gallina siempre.
They turn raw data into foresight. So next time, we'll be ready. Tokens decode the laws of physics to get us there faster. And take us further. Tokens see disease before it takes hold. They help us unravel the language of life and learn what makes us tick. Tokens connect the dots so we can protect our most noble creatures. They turn potential into plenty. And help us harvest our bounty.
Qué guapo esto, ¿eh? Con drones para ir recogiendo las frutas.
Tokens don't just teach robots how to move, but to bring joy.
Este es el robotito que salió el año pasado en el escenario.
To lend us a hand.
Los robots de One X.
Life within reach. together, we take the next great leap to bravely go where no one has gone before.
¿Veis? Son las oficinas de NVIDIA, lo sabía.
Is where it all begins.
Ahí estuve el año pasado yo. Ahí estuvimos.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Viene. Decidme si mi voz se oye bien por encima
GTC!
el loco de Jensen. Es una película de Avatar, esta es la música.
What an amazing year. We wanted to do this at NVIDIA.
A ver si hay subtítulos.
So through the magic of artificial intelligence,
No hay subtítulos.
we're going to bring you to NVIDIA's headquarters. I think I'm bringing you to NVIDIA's headquarters.
Ay, ay. Qué guapo, eso está hecho con Gaussian splatting.
What do you think?
La animación
This
que
is-
se ha visto.
This is where we work. This is where we work. What an amazing year it was. And we have a lot of incredible things to talk about. And I just want you to know that I'm up here without a net. There are no scripts, there's no teleprompter, and I've got a lot of things to cover, so let's get started. First of all, I want to thank all of the sponsors, all the amazing people who are part of this conference. Just about every single industry is represented.
Vale,
Healthcare is here.
ahora me tenéis que escuchar mejor.
Transportation, retail, gosh, the computer industry. Everybody in the computer industry is here. And so it's really, really terrific to see all of you.
Ahora me tenéis que
Thank you for
escuchar mejor, ¿no?
sponsoring
Se
it.
supone.
GTC started
Va,
with
perfecto.
GeForce. It all started with GeForce. And today, I have here a GeForce 5090.
Mira, va a hablar de la GPU que os podéis
5090,
llevar.
Unbelievably, 25 years later, 25 years after we started working on GeForce,
Este señor, ¿qué edad
GeForce
tiene,
is
tío?
sold out all over the world. This is the 5090, the Blackwell generation, and comparing it to the 4090, look how it's 30% smaller in volume. It's 30% better at dissipating energy and incredible performance. Hard to even compare, and the reason for that is because of artificial intelligence. GeForce brought CUDA to the world.
Tiene 62
CUDA
años, tío.
enabled AI, and AI has now come back to revolutionize computer graphics. What you're looking at is real-time computer graphics, 100% path traced. For every pixel that's rendered, artificial intelligence predicts the other 15.
Me ha gustado la de ciclos de carga, ¿eh?
Think about this for a second. For every pixel that we mathematically rendered, artificial intelligence inferred the other 15. And it has to do so with so much precision that the image looks right, and it's temporally accurate, meaning that from frame to frame to frame, going forward or backwards because it's computer graphics, it has to stay temporally stable. Incredible. Artificial intelligence has made extraordinary progress. It has only been 10 years. Now, we've been talking about AI for a little long.
Este es como yo, que me quedé anclado en que solo hay una década de Deep Learning y realmente ha dicho, solo han sido 10 años. A ver, ya vamos para 12, 13 años, pero le pasa un poco igual que a mí.
Then generative AI.
2012 fue el punto.
Years, we've largely focused on generative AI, teaching an AI how to translate from one modality to another modality, text to image, image to text to video, amino acids to proteins, properties to chemicals, all kinds of different ways that we can use AI to generate content. Generative AI fundamentally changed how computing is done. From a retrieval computing model, we now have a generative computing model. Whereas almost everything that we did in the past was about creating content in advance, storing multiple versions of it, and fetching whatever version we think is appropriate at the moment of use. Now, AI understands the context, understands what we're asking, understands the meaning of our request, and generates what it knows. If it needs, it'll retrieve information, augments its understanding, and generate answer for us. Rather than retrieving data, it now generates answers. Fundamentally changed how computing is done. Every single layer of computing has been transformed. The last several years, the last couple of 2-3 years, major breakthrough happened. Fundamental advance in artificial intelligence. We call it agentic AI. Agentic AI basically means that you have an AI that has agency. It can perceive and understand the context of the circumstance. It can reason, very importantly, it can reason about how to answer or how to solve a problem. And it can plan in action. It can plan and take action. It can use tools because it now understands multimodality information. It can go to a website and look at the format of the website, words and videos, maybe even play a video. Learns from what it learns from that website, understands it, and come back and use that information, use that newfound knowledge to do its job. Agentic AI. At the foundation of agentic AI, of course, something that's very new, reasoning. And then, of course, the next wave is already happening. We're going to talk a lot about that today.
Robótica.
Robotics, which has been enabled by physical AI. AI that understands.
¿Vale? Me gusta mucho el diagrama porque es esto, ¿vale? Esto es lo que estamos viviendo. Quizás se ha adelantado un poco, él ha dicho que en los últimos años hemos tenido avances en Agentic AI. Yo diría que en los últimos años hemos tenido avances en Generative AI, es la realidad. Esto ya estamos en un punto de madurez y estamos entrando en esta fase de aquí, Agentic AI, y empezamos a ver ejemplos interesantes como Manus AI, que hablé en el otro canal. Y también estamos empezando a ver conatos de esto y se hablará mucho en esta charla de robótica, pero tengo que decir que este 2025 soy mucho más creyente en que la oleada de robótica va a ser real, más que el año pasado. Y fíjate que el año pasado sí lo veía con una posibilidad.
As a result, GTC is
Pero
now jam-packed.
Están pasando
The only
cositas.
way to hold more people at GTC is we're going to have to grow San Jose. And we're working on it. We got a lot of land to work with. We got to grow San Jose.
Está diciendo que tienen que hacer San José más grande para poder hacer un GTC mayor. San
So that we can
José,
make GTC I have to just,
no hay nada.
you know,
Es,
as I'm
no
standing
sé,
here, I wish all of
una
you
ciudad
could
que me
see what I
pareció
see.
que estaba muerta.
And we're in the middle of a stadium.
San Francisco, Simón.
And last year was the first year back that we did this live, and it was like a rock concert, and it was described, GTC was described as the Woodstock of AI, and this year it's described as the Super Bowl of AI.
¿Qué le gusta? No os hacéis una idea de lo grande que es este lugar. O sea, esto que estáis viendo aquí es como la parte que se ve desde las cámaras, pero
Everybody
es
wins at this Super Bowl.
un estadio enorme.
Everybody's a
enorme.
winner. And so every single year, more people come because AI is able to solve more interesting problems for more industries and more companies. And this year, we're going to talk a lot about agentic AI and physical AI. At its core, what enables each wave and each phase of AI, three fundamental matters are involved. The first is how do you solve the data problem? And the reason why that's important is because AI is a data-driven computer science approach. It needs data to learn from. It needs digital experience to learn from, to gain to learn knowledge and to gain digital experience. How do you solve the data problem? The second is how do you solve the training problem without human in the loop? The reason why human in the loop is fundamentally challenging is because we only have so much time, and we would like an AI to be able to learn at superhuman rates, at super real-time rates, and to be able to learn at a scale that no humans can keep up with. And so the second question is, how do you train the model? And the third is, how do you scale? How do you find an algorithm whereby the more resource you provide, whatever the resource is, the smarter the AI becomes? The scaling law. Well, this last year, this is where almost the entire world got it wrong. The computation requirement, the scaling law of AI is more resilient and in fact,
están hablando de
accelerated.
De
The
forma
amount of computation we need at this point as a result of agentic AI, as a result of reasoning, is easily 100 times more than we thought we needed this time last year. And let's reason about why that's true. The first part is let's just go from
estoy de acuerdo.
what the AI can do. Let me work backwards.
Ha habido
Agentic AI, as I mentioned,
no se han metido
at
con
its
DeepSeek,
foundation,
se han
is
metido con
reasoning.
la gente que interpretó
We now
mal
have AIs
que la ley de escalas
that
estaba
can reason,
acabada.
which is fundamentally about breaking a problem down step by step. Maybe it approaches a problem in a few different ways and selects the best answer. Maybe it solves the same problem in a variety of ways and ensure it has the same answer, consistency checking. Or maybe after it's done deriving the answer, it plugs it back into the equation, maybe a quadratic equation, to confirm that in fact that's the right answer, instead of just one shot blurbing it out. Remember, 2 years ago when we started working with ChatGPT, a miracle as it was, many
2
complicated
años
questions
de
and many simple
ChatGPT.
questions, it simply can't get right, and it's understandably so.
2 años y medio, tío.
It took a one shot, whatever it learned by studying pre-trained data, whatever it saw from other experiences, pre-trained data, it does a one shot, blurps it out, like a savant. Now, we have AIs that can reason step by step by step, using a technology called chain of thought, best of n, consistency checking, a variety of different path planning, a variety of different techniques. We now
Jensen.
have AIs that can reason, break a problem down, reason, step by step by step. Well, you could imagine, as a result, the number of tokens we generate, and the fundamental technology of AI is still the same. Generate the next token, predict the next token. It's just that the next token now makes up step one. Then the next token after that, after it generates step one, that step one has gone into the input of the AI again as it generates step two, and step three, and step four. So instead of just generating one token or one word after next, it generates a sequence of words that represents a step of reasoning. The amount of tokens that's generated as a result is substantially higher, and I'll show you in a second. Easily 100 times more. Now, 100 times more, what does that mean? Well, it could generate 100 times more tokens, and you can see that happening, as I explained previously. Or the model is more complex.
Que me parece
It
interesante toda
generates
esta
10
parte.
times more tokens, and in order for us to keep the model responsive, interactive, so that we don't lose our patience waiting for it to think, we now have to compute 10 times faster. And so 10 times tokens, 10 times faster, the amount of computation we have to do is 100 times more easily. And so you're going to see this in the rest of the presentation. The amount of computation we have to do for inference
Básicamente lo que está hablando es del tema de que ahora las IAs que razonan generan muchos más tokens, generan 100 veces más tokens, dice,
an AI how to do what I just
y
described.
que por tanto hay más necesidad de
How to
computación.
execute this chain of
Obvio.
thought. Well, one method is you have to teach the AI how to reason. And as I mentioned earlier, in training, there are two fundamental problems we have to solve. Where does the data come from? Where does the data come from? And how do we not have it be limited by human in the loop? There's only so much data and so much human demonstration we can perform. And so this is the big breakthrough in the last couple of years.
Cuando encuentre un huequillo, saltamos a YouTube y pongo los subtítulos automáticos, que me lo estáis pidiendo, pero vamos a esperar un momento.
As it attacks or tries to engage solving a problem step by step. Well, we have many problems that have been solved in the history of humanity where we know the answer. We know the equation of a quadratic equation, how to solve that. We know how to solve a Pythagorean theorem, the rules of a right triangle. We know many, many rules of math and geometry and logic and science. We have puzzle games that we could give it, constraint type of problems like Sudoku. Those kind of problems, on and on and on. We have hundreds of these problem spaces where we can generate millions of different examples and give the AI hundreds of chances to solve it step by step as we use reinforcement learning to reward it as it does a better and better job. So as a result, you take hundreds of different topics, millions of different examples, hundreds of different tries, each one of the tries generating tens of thousands of tokens. You put that all together, we're talking about trillions and trillions of tokens in order to train that model. And now with reinforcement learning, we have the ability to generate an enormous amount of tokens. Synthetic data generation, basically using a robotic approach to teach an AI. The combination of these two things has put an enormous challenge of computing in front of the industry. And you can see that the industry is responding. This is, what I'm about to show you is Hopper shipments of the top 4 CSPs. The top 4 CSPs. They're the ones with the public clouds. Amazon, Azure, GCP, and OCI.
Nos va a enseñar la demanda de...
Not the AI companies, that's not included. Not all the startups, not included. Not enterprise, not included. A whole bunch of things not included, just those 4. Just to give you a sense of comparing the peak year of Hopper and the first year of Blackwell.
La demanda de hoppers que se han pedido por parte de 4 empresas.
So you can kind of see that, in fact, AI is going through an inflection point. It has become more useful because it's smarter, it can reason.
Madre mía, que se están forrando.
It is more used. You can tell it's more used because whenever you go to ChatGPT these days, it seems like you have to wait longer and longer and longer, which is a good thing. It says a lot of people are using it with great effect. And the amount of computation necessary to train those models and to inference those models has grown tremendously. So in just 1 year, and Blackwell has just started shipping, in just 1 year, you could see the incredible growth in AI infrastructure. Well, that's being reflected in computing across the board. We're now seeing, and this is, the purple is the forecast of analysts about the increase of capital expense of the world's data centers, including CSPs and enterprise and so on, the world's data centers through the end of the decade, so 2030. I've said before that I expect data center build-out to reach $1 trillion, and I am fairly certain we're going to reach that very soon. 2 dynamics is happening at the same time. The first dynamic is that the vast majority of that growth is likely to be accelerated. Meaning, we've known for some time that general purpose computing has run its course, and that we need a new computing approach. And the world is going through a platform shift from hand-coded software running on general purpose computers to machine learning software running on accelerators and GPUs. This way of doing computation is at this point past this tipping point. And we are now seeing the inflection point happening, the inflection happening in the world's data center buildouts. So the first thing is a transition in the way we do computing. Second is an increase in recognition that the future of software requires capital investment. Now, this is a very big idea. Whereas in the past, we wrote the software and we ran it on computers, in the future, the computer is going to generate the tokens for the software. And so the computer has become a generator of tokens, not a retrieval of files. From retrieval-based computing to generative-based computing, from the old way of doing data centers to a new way of building these infrastructure, and I call them AI factories. They're AI factories because it has one job and one
Todo esto
job
es para
only,
justificar que van a
generating
seguir
these incredible
vendiendo, ¿vale?
tokens
Que el
that we
futuro
then
va a requerir de
reconstitute into
grandes
music,
inversiones de capital
into
para
words,
tener
into
centros de
videos,
computación,
into
para ejecutar mucha de la IA
research,
generativa,
into
que va a estar
chemicals or
resolviendo pues, gran
proteins.
parte de los
We
problemas, ¿no?
reconstitute
Que
it
el
into
software
all
ya no va a
kinds
ser
of
un software
information
que
of
se
different types.
ejecute
So the
en un
world is
equipo
going
normal,
through
sino que van a
a
ser generadores de
transition
tokens que
in not just the amount of data
hagan
centers
cosas,
that will
que
be built,
generen
but also
que
how
resuelvan
it's
tareas
built.
agénticas, que generen contenido,
Well, everything in the data center will be accelerated. Not all of it's AI.
Es la proyección que se ha
And
hecho,
I want
¿no?
to say a
De
few
cómo va a
words
seguir
about
la
this.
evolución de
You know,
la inversión en CAPEX por parte de las empresas.
This slide is
Y al lado la ganancia de
genuinely
NVIDIA.
my favorite. And the reason for that is because for all of you who've been coming to GTC all of these years, you've been listening to me talk about these libraries this whole time. This is in fact what GTC is all about, this one slide. And in fact, a long time ago, 20 years ago,
No me
this
gusta
is
el
the
rollo
only
dibujado a mano
slide
que le
we
han dado
had.
este año.
One library after another library after another library. You can't just accelerate software, just as we needed an AI framework in order to create AIs, and we accelerate the AI frameworks. You need frameworks for physics and biology and multi-physics and all kinds of different quantum physics. You need all kinds of libraries and frameworks. We call them CUDA-X libraries, acceleration frameworks for each one of these fields of science. And so this first one is incredible. This is CuPy numeric. NumPy is the #1 most downloaded Python library, most used Python library in the world. Downloaded 400 million times this last year. cuLitho is and CuPy numeric is a zero change drop-in acceleration for NumPy. So if any of you are using NumPy out there, give CuPy numeric a try. You're going to love it. A cuLitho, a computational lithography library.
Culito, siempre nos gusta el culito.
Over the course of 4 years, we've
Que es
now taken
CUDA
the
para
entire
litografía.
process of processing lithography, computational lithography, which is the second factory in a fab. There's the factory that manufactures the wafers, and then there's the factory that manufactures the information to manufacture the wafers. Every industry, every company that has factories will have 2 factories in the future. The factory for what they build and the factory for the mathematics, the factory for the AI. Factory for cars, factory for AIs for the cars, factory for smart speakers, and factories for AI for the smart speakers. And so cuLitho is our computational lithography, TSMC, Samsung, ASML, our partners Synopsys, Mentor, incredible support all over. I think that this is now at its...
Entonces, este rollo justo de las IAs que se aplican a puntos claves del proceso de fabricación de chips que permiten entrenar a más IAs, es de las cosas que más me gustan, porque está como la ordenación de piezas que permite esta idea de una explosión de inteligencia, donde puede haber un ciclo virtuoso en el que una mejora hace que ese proceso se mejore y por tanto haya una mejora virtuosa, ¿no? que sea incremental. Me gusta mucho ese rollo.
By the limits of information theory, because there's only so much information spectrum we can get, not if we add AI to it. CuOpt, numerical or mathematical optimization. Almost every single industry uses this when you plan seats and flights, inventory and customers, workers and plants, drivers and riders, so on and so forth, where we have multiple constraints, a whole bunch of variables, and you're optimizing for time, profit, quality of service, usage of resource, whatever it happens to be. NVIDIA uses it for our supply chain management. cuOpt is an incredible library. It takes what would take hours and hours, and it turns into seconds. The reason why that's a big deal is so that we can now explore much larger space. We announced that we are going to open source cuOpt. Almost everybody is using either Gurobi or IBM Cplex or FICO. We're working with all three of them. The industry is so excited. We're about to accelerate the living daylights out of the industry. Parabricks for gene sequencing and gene
Jensen ya,
analysis. Monai is the world's
que tenéis un montón de librerías, ya lo sabemos.
imaging
Ya.
library.
Next.
Earth-2 multi-physics for predicting
Como va sin-
in very high resolution.
Como va sin
local
guión,
weather,
claro, él va hablando
Quantum
ahí.
and CUDA Q. We're going to have our first quantum day here at GTC. We're working with just about everybody in the ecosystem, either helping them research on quantum architectures, quantum algorithms, or in building a classical accelerated quantum heterogeneous architecture. And so really exciting work there. Q equivariance and Q tensor for tensor contraction, quantum chemistry. Of course, this stack is world famous. People think that there's one piece of software called CUDA, but in fact, on top of CUDA is a whole bunch of libraries that's integrated into all different parts of the ecosystem and software and infrastructure in order to make AI possible. I've got a new one here to announce today. QDSS, our sparse solvers, really important for CAE.
Voy a intentar dar el salto a YouTube para poner los subtítulos automáticos, ¿vale? Vais a ver un poco de glitch.
Working with Cadence and Synopsys and Ansys and Dassault and all of the systems companies, we've now made possible just about every important EDA and CAE library to be accelerated. What's amazing is until recently, NVIDIA has been using general purpose computers running software super slowly to design accelerated computers for everybody else. And the reason for that is because we never had that software, that body of software optimized for CUDA until recently. And so now our entire industry is going to get supercharged as we move to accelerated computing. QDF, a data frame for structured data. We now have a drop-in acceleration for Spark and drop-in acceleration for Pandas. Incredible. And then we have Warp, a library for physics that runs in a Python library for physics for CUDA. We have a big announcement there. I will save it in just a second. This is just a sampling of the libraries that make possible accelerated computing. It's not just CUDA. We're so proud of CUDA. But if not for CUDA and the fact that we have such a large installed base, none of these libraries would be useful for any of the developers who use them. For all the developers that use them, you use it because, one, it's going to give you incredible speed up.
Me interesa un poco hablar de esto porque es como una forma de decir, no solo somos relevante en nuestro mode, nuestra ventaja competitiva no es solamente CUDA, sino es todas las librerías que está presentando aquí. Pero eso está dándole tanto hincapié porque les interesa mucho hacer valer que tienen una ventaja competitiva mayor que AMD y el resto de la competencia.
Your amazing software can reach everyone. And so we've now reached the tipping point of accelerated computing. CUDA has made it possible. And all of you, this is what GTC is about, the ecosystem. All of you made this possible. And so we made a little short video for you. Thank you. To the creators, the pioneers, the builders of the future, CUDA was made for you.
Grande, CUDA, grande.
Since 2006, 6 million developers in over
Sin CUDA,
200 countries
nada de esto
have
estaría
used
ocurriendo.
CUDA
La revolución
and
del deep learning.
transformed computing. With over 900 CUDA-X libraries and AI models, you're accelerating science, reshaping industries, and giving machines the power to see, learn, and reason. Now, NVIDIA Blackwell is 50,000 times faster than the first CUDA GPU. These orders of magnitude gains in speed and scale are closing the gap between simulation and real-time digital twins.
for you, this is still just the beginning. We can't wait to see what you do next.
Cuidado con K, la versión anarquista.
I love what we do. I love even more what you do with it. And one of the things that most touch me, in my 33 years doing this, one scientist said to me, Jensen, because of your work, I can do my life's work in my lifetime. And boy, if that doesn't touch you, well, you got to be a corpse. So this is all about you guys. Thank you. All right, so we're going to talk about AI.
Vamos.
But you know, AI started in the cloud. It started in the cloud for a good reason, because it turns out that AI needs infrastructure. It's machine learning. If the science says machine learning, then you need a machine to do the science. And so machine learning requires infrastructure, and the cloud data centers had infrastructure. They also have extraordinary computer science, extraordinary research, the perfect circumstance
Qué
for
guapo estaría
AI
un trivial
to
con
take
estas
off in the
categorías.
cloud
Lo
and the
ganamos.
CSPs. But that's not where AI is limited to. AI will go everywhere. And we're going to talk about AI in a lot of different ways. And the cloud service providers, of course, they like our leading edge technology. They like the fact that we have full stack, because accelerated computing, as you know, as I was explaining earlier, is not about the chip. It's not even just the chip in the library, the programming model. It's the chip, the programming model, and a whole bunch of software that goes on top of it. That entire stack is incredibly complex. Each one of those layers, each one of those libraries is essentially like SQL. SQL, as you know, is called in-storage computing. It was the big revolution of computation by IBM. SQL is one library, just imagine. I just showed you a whole bunch of
Tengo
them.
dos tazas de
And in the
NVIDIA.
case of AI, there's a
El
whole
problema es
bunch
que no sé
more.
cuándo llegaron a mi casa,
So
pero
the
las tengo.
stack is complicated. They also love the fact that CSPs love that NVIDIA CUDA developers are CSP customers, because in the final analysis, they're building infrastructure for the world to use. And so the rich developer ecosystem is really valued and really deeply appreciated. Well, now that we're going to take AI out to the rest of the world has different system configurations, operating environment differences, domain-specific library differences, usage differences. And so AI, as it translates to enterprise IT, as it translates to manufacturing, as it translates to robotics or self-driving cars, or even companies that are starting GPU clouds. There's a whole bunch of companies, maybe 20 of them, who started during the NVIDIA time. And what they do is just one thing. They host GPUs. They call themselves GPU clouds. And one of our great partners, CoreWeave, is in the process of going public, and we're super proud of them. And so GPU clouds, they have their own requirements. But one of the areas that I'm super excited about is edge. And today we announced today that Cisco, NVIDIA, T-Mobile, the largest telecommunications company in the world, Cerberus ODC, are going to build a full stack for radio networks here in the United States. And that's going to be the second stack. So that this current stack we're announcing today will put AI into the edge. Remember, $100 billion of the world's capital investments each year is in the radio networks and all of the data centers provisioning for communications. In the future, there is no question in my mind that's going to be accelerated computing infused with AI. AI will do a far, far better job adapting the radio signals, the massive MIMOs, to the changing environments and the traffic conditions. Of course it would. Of course we would use reinforcement learning to do that. Of course MIMO is essentially one giant radio robot. Of course it is. And so we will, of course, provide for those capabilities. Of course, AI could revolutionize communications. You know, when I call home, you don't have to say but that few words because my wife knows where I work.
No he entendido mucho el caso que ha dicho de que querían optimizar con Reinforcement Learning. No sé si es como el tema de sincronizar las señales de comunicación.
And oftentimes, just a few words, you communicated a whole bunch. The reason for that is because of context and human prior knowledge. Well, combining those capabilities could revolutionize communications. Look what it's doing for video processing. Look what I just described earlier in 3D graphics. And so, of course, we're going to do the same for Edge. So I'm super excited about the announcement that we made today. T-Mobile, Cisco, NVIDIA, Cerberus ODC are going to build a full stack.
Vale, bien.
Well, AI is going to go into every industry. That's just one. One of the earliest industries that AI went into was autonomous vehicles. The moment I saw AlexNet, and we've been working on computer vision for a long time, the moment I saw AlexNet was such an inspiring moment, such an exciting moment. It caused us to decide to go all in on building self-driving cars. So we've been working on self-driving cars now for over a decade. We build technology that almost every single self-driving car company uses. It could be either in the data center. For example, Tesla uses lots of NVIDIA GPUs in the data center. It could be in the data center or the car. Waymo and Wave uses NVIDIA computers in data centers as well as the car. It could be just in the car.
Es que están en todos lados los malditos NVIDIA.
Or they use all of our software in addition.
¿Quieres entrenar un vehículo autónomo? Necesitas computación en la nube. ¿Quieres ejecutar en el vehículo? Necesitas GPUs en el coche.
The training computer, the simulation computer, and the robotics computer, the self-driving car computer, all the software stack that sits on top of it, models and algorithms, just as we do with all of the other industries that I've demonstrated. And so today, I'm super excited to announce that GM has selected NVIDIA to partner with them to build their future self-driving car fleet.
Vale. Se han aliado con General Motors para hacer vehículos autónomos. Ya NVIDIA tuvo un proyecto de vehículos autónomos con Mercedes, creo, hace años. 2017-2018. Pero claro, en aquel momento los vehículos autónomos cayeron un poco en declive. Pero ahora sí estamos en un punto en el que tiene sentido.
AI for enterprise, so they can revolutionize the way they work, design cars and simulate cars, and then also AI for in the car. So AI infrastructure for GM, partnering with GM, and building with GM their AI. So I'm super excited about that. One of the areas that I'm deeply proud of, and it rarely gets any attention, is safety, automotive safety. It's called halos. In our company, it's called halos. Safety requires technology from silicon to systems, the system software, the algorithms, the methodologies, everything from diversity to ensuring diversity, monitoring and transparency, explainability. All of these different philosophies have to be deeply ingrained into every single part of how you develop the system and the software. We're the first company in the world, I believe, to have every line of code safety assessed. 7 million lines of code safety assessed. Our chip, our system software, and our algorithms are safety assessed by third parties that crawl through every line of code to ensure that it is designed to ensure diversity, transparency, and explainability.
De estar en San Francisco,
we also
mi capacidad de creer en los vehículos autónomos cambió tanto, y es una cosa que solamente te das cuenta cuando estás ahí, cuando ves toda la ciudad llena de Waymos funcionando y de Teslas funcionando. Y en Europa y fuera de muchas ciudades de Estados Unidos que no sea San Francisco, Es que no lo vives. Y como no lo vives, parece que no está pasando. Pero está pasando. O sea, los vehículos autónomos ya funcionan. ¿Vale? Ya no es una cosa de que va a llegar. Ya funcionan. Es una pasada. Y el año pasado cuando fui, en marzo, estaba todavía en beta privada, pero es que ya luego en septiembre cuando volví, ya era beta pública. Y entró en Los Ángeles, y entró en Phoenix, y entró en varias ciudades. Y en China también está pasando. Hay un montón de empresas en China que ya están colocando vehículos autónomos también. Es decir, técnicamente es una realidad. Otra cosa es todo lo demás. La geopolítica, la regulación, todo eso está ahí.
NVIDIA is accelerating AI development for AVs with Omniverse and Cosmos. Cosmos prediction and reasoning capabilities support AI-first AV systems that are end-to-end trainable with new methods of development. Model distillation, closed-loop training, and synthetic data generation. First, model distillation. Adapted as a policy model, Cosmos's driving knowledge transfers from a slower, intelligent teacher to a smaller, faster student inferenced in the car. The teacher's policy model demonstrates the optimal trajectory, followed by the student model learning through iterations, until it performs at nearly the same level as the teacher. The distillation process bootstraps a policy model, but complex scenarios require further tuning. Closed-loop training enables fine-tuning of policy models. Log data is turned into 3D scenes for driving closed-loop in physics-based simulation using Omniverse neural reconstruction. Variations of these scenes are created to test a model's trajectory generation capabilities. Cosmos Behavior Evaluator can then score the generated driving behavior to measure model performance. Newly generated scenarios and their evaluation create a large dataset for closed-loop training.
Esto está guapísimo, que es la idea de generar modelos del mundo que te permitan simular el entrenamiento del coche y simular escenarios de, vale, si cojo esta carretera, si voy a la derecha en vez de ir de frente, ¿qué debería de pasar? Y que el coche pueda planificar, anticiparse antes de ejecutar la acción.
Omniverse builds detailed 4D driving environments by fusing
de esto hay una
maps
empresa
and
en UK
images
que se llama
and generates a digital twin of the real
que lo
world,
hacen muy bien. Tienen trabajos muy
including
chulos sobre eso.
segmentation, to guide Cosmos by classifying each pixel. Cosmos then scales the training data by generating accurate and diverse scenarios, closing the sim-to-real gap. Omniverse and Cosmos enable AVs to learn, adapt, and drive intelligently, advancing safer mobility.
NVIDIA is the perfect company to do that. Gosh.
Compradme.
That's our destiny. Use AI to recreate AI. The technology that we showed you there is very similar to the technology that you're enjoying to take you to a digital twin we call NVIDIA. All right, let's talk about data centers.
Qué guapo. Gaussian Splatting. Renderización volumétrica.
That's not bad, huh? Gaussian splats, just in case. Gaussian splats.
Ahí lo he dicho. Muy
let's
bien.
talk about data centers.
¿Cómo sabe Jensen, ¿Cómo está preparado el tío?
And this is what it looks like. It's an incredible. You know, for people, for us, this is a sight of beauty. Would you agree? This is. How is this not beautiful?
Madre mía.
How is this not beautiful? Well, this is a big deal because we made a fundamental transition in computer architecture. I just want you to know that, in fact, I've shown you a version of this about 3 years ago. It was called Grace Hopper, and the system was called Ranger. The Ranger system is about maybe about half of the width of the screen.
Neveras por detrás, total.
And it was the world's first NVLink 32. 3 years ago, we showed Ranger working, and it was way too large, but it was exactly the right idea. We were trying to solve scale up. Distributed computing is about using a whole lot of different computers working together to solve a very large problem. But there's no replacement for scaling up before you scale out. Both are important, but you want to scale up first before you scale out. Well, scaling up is incredibly hard. There is no simple answer for it. You're not going to scale it up, you're not going to scale it out like Hadoop. Take a whole bunch of commodity computers, hook it up into a large network, and do in-storage computing using Hadoop. Hadoop was a revolutionary idea, as we know. It enabled hyperscale data centers to solve problems of gigantic sizes and using off-the-shelf computers. However, the problem we're trying to solve is so complex that scaling in that way would have simply cost way too much power, way too much energy. It would have never, deep learning would have never happened. And so the thing that we had to do was scale up first. Well, this is the way we scaled up. I'm not going to lift this. This is 70 pounds. This is the last generation system architecture is called HGX. This revolutionized computing as we know it. This revolutionized artificial intelligence. This is 8 GPUs. 8 GPUs. Each one of them is kind of like this. Okay, this is 2 GPUs, 2 Blackwell GPUs in one Blackwell package. 2 Blackwell GPUs in one Blackwell package. And there are 8 of these underneath this. Okay? And this connects into what we call NVLink 8. This then connects to a CPU shelf.
Todo esto, si no me equivoco, toda la altura que tiene esto es el para refrigerar, me imagino, ¿no? Los disipadores y todo esto. Toda la altura, porque al final los chips estarán por aquí abajo.
Like that. So
Vaya
there's
bicho.
dual CPUs, and that sits on top. And we connect it over PCI Express, and then many of these get connected with InfiniBand, which turns into what is an AI supercomputer. This is the way it was in the past. This is how we started. Well, this is as far as we scaled up before we scaled out. But we wanted to scale up even further. And I told you that Ranger took this system and scaled it up by another factor of 4. And so we had NVLink 32, but the system was way too large. And so we had to do something quite remarkable, re-engineer how NVLink worked and how scale-up worked. And so the first thing that we did was we said, listen, the NVLink switches are in this system embedded on the motherboard. We need to disaggregate the NVLink system and take it out. So this is the NVLink system. Okay, this is an NVLink switch. This is the highest performance switch the world's ever made. And this makes it possible for every GPU to talk to every GPU at exactly the same time at full bandwidth. Okay, so this is the NVLink switch. We disaggregated it, we took it out, and we put it in the center of the chassis.
Que parece una masterclass esto, tío.
There are 18 of these switches in 9 different racks, 9 different switch trays, we call them. And then the switches are disaggregated. The compute is now sitting in here. This is equivalent to these 2 things in compute. What's amazing is this is completely liquid cooled. And by liquid cooling it, we can compress all of these compute nodes into one rack. This is the big change of the entire industry. All of you in the audience, I know how many of you are here. I want to thank you for making this fundamental shift from integrated NVLink to disaggregated NVLink, from air-cooled to liquid-cooled, from 60,000 components per computer or so to 600,000 components per rack. 120 kilowatts, fully liquid cooled, and as a result, we have a 1 exaflops computer in one rack. Isn't it incredible? So this is the compute node. This is the compute node, okay? And that now fits in one of these. Now 3,000 pounds, 5,000 cables, about 2 miles worth. Just an incredible electronics. 600,000 parts, I think that's like 20 cars. 20 cars worth of parts. And integrates into one supercomputer. Well, our goal is to do this. Our goal is to do scale up. And this is what it now looks like. We essentially wanted to build this chip. It's just that no reticle limits can do this. No process technology can do this. It's 130 trillion transistors. 20 trillion of it is used for computing.
¿Cuántos nanómetros era Blackwell?
You can't reasonably build this
nanómetros.
anytime soon. And so the way to solve this problem is to disaggregate it, as I described, into the Grace Blackwell NVLink 72 rack. But as a result, we have done the ultimate scale-up. This is the most extreme scale-up the world has ever done. The amount of computation that's possible here, the memory bandwidth, 570 terabytes per second. Everything in this machine is now in T's. Everything's a trillion. And you have an exaflops, which is 1,000,000 trillion floating point operations per second. Well, the reason why we wanted to do this is to solve an extreme problem. And that extreme problem, a lot of people misunderstood to be easy. And in fact, it is the ultimate extreme computing problem, and it's called inference. And the reason for that is very simple. Inference is token generation by a factory, and a factory is revenue and profit generating, or lack of. And so this factory has to be built with extreme efficiency, with extreme performance, because everything about this factory directly affects your quality of service, your revenues, and your profitability. Let me show you how to read this chart, because we're going to come back to this a few more times. Basically, you have two axes. On the x-axis is the tokens per second. Whenever you put a prompt into ChatGPT, what comes out is tokens. Those tokens are reformulated into words. You know, it's more than a token per word, okay? And they'll tokenize things like THE could be used for the, it could be used for them, it could be used for theory, it could be used for theatrics, it could be used for all kinds of, okay? And so THE is an example of a token. They reformulate these tokens to turn into words. Well, we've already established that if you want your AI to be smarter, you want to generate a whole bunch of tokens. Those tokens are reasoning tokens, consistency checking tokens, coming up with a whole bunch of ideas so they can select the best of those ideas tokens. And so those tokens, it might be second guessing itself. It might be, is this the best work you could do? And so it talks to itself just like we talk to ourselves. And so the more tokens you generate, the smarter your AI. But
esa idea mola porque es una idea nueva de septiembre del año pasado. Cuando sale el Test Time Compute, de repente hemos vinculado que generar tokens más rápido es tener una inteligencia artificial más inteligente, ¿vale? Y podemos hablar incluso de densidad de inteligencia, de cantidad de tokens por segundo que podemos generar como una medida de más inteligencia. Que es un poco lo que está comentando, ¿no? Que es el eje X de esta gráfica.
If you take too long to answer a question, the customer's not going to come back. This is no different than web search. There is a real limit to how long it can take before it comes back with a smart answer. And so you have these two dimensions that you're fighting against. You're trying to generate a whole bunch of tokens, but you're trying to do it as quickly as possible. Therefore, your token rate matters. So you want your tokens per second for that one user to be as fast as possible. However, in computer sciences and factories, there's a fundamental tension between latency response time and throughput. And the reason is very simple. If you're in the large, high-volume business, you batch up, it's called batching, you batch up a lot of customer demand, and you manufacture a certain version of it for everybody to consume later. However, from the moment that they batched up and manufacture whatever they did, to the time that you consumed it, could take a long time. So no different for computer science, no different for AI factories that are generating tokens. And so you have these two fundamental tensions. On the one hand, you would like the customer's quality of service to be as good as possible, smart AIs that are super fast. On the other hand, you're trying to get your data center to produce tokens for as many people as possible so you can maximize your revenues. The perfect answer is to the upper right. Ideally, the shape of that curve is a square that you could generate very fast tokens per person up until the limits of the factory, but no factory can do that. And so it's probably some curve, and your goal is to maximize the area under the curve, okay, the product of X and Y, and the further you push out, more likely it means the better of a factory that you're building. Well, it turns out that in tokens per second for the whole factory and tokens per second response time, one of them requires enormous amount of computation, flops, and then the other dimension requires an enormous amount of bandwidth and flops. And so this is a very difficult problem to solve. The good answer is that you should have lots of flops and lots of bandwidth and lots of memory and lots of everything. That's the best answer to start, which is the reason why this is such a great computer. You start with the most flops you can, the most memory you can, the most bandwidth you can, of course the best architecture you can, the most energy efficiency you can, and you have to have a programming model that allows you to run software across all of this insanely hard so that you could do this. Now let's just take a look at this one demo to give you a tactile feeling of what I'm talking about. Please play it.
Traditional LLMs capture foundational knowledge, while reasoning models help solve complex problems with thinking
que pone aquí, chicos.
Here, a prompt asks to seat people around a wedding table while adhering to constraints like traditions, photogenic angles, and feuding family members.
Lo dije que iba a salir DeepSeek.
Traditional LLM answers quickly with under 500 tokens. It makes mistakes in seating the guests, while the reasoning model thinks with over 8,000 tokens to come up with the correct answer. It takes a pastor to keep the peace.
Okay. As all of you know, if you have a wedding party of 300 and you're trying to find the perfect, the optimal seating for everyone, that's a problem that only AI can solve or a mother-in-law can solve. And so that's one of those problems that co-op cannot solve.
Si tienes que sentar a 300 personas en una boda, eso es un problema que solo una IA puede resolver o una suegra. Eso es lo que acaba de decir Jensen.
Okay, so what you see here is that we gave it a problem that requires reasoning, and you saw R1 goes off and it reasons about it, tries all these different scenarios, and it comes back and it tests its own answer. It asks itself whether it did it right. Meanwhile, the last generation language model does a one-shot. So the one-shot is 439 tokens. It was fast, it was effective, but it was wrong. So it was 439 wasted tokens. On the other hand, in order for you to reason about this problem, and this is just that was actually a very simple problem. You just give it a few more few more difficult variables, and it becomes very difficult to reason through. And it took
Llama todavía no tiene
8,000,
versión
almost 9,000
razonadora
tokens.
todavía,
And it
pero
took a lot more
lo van a
computation
sacar.
because the model's more complex. Okay, so that's one dimension. Before I show you some results, let me explain something else. So the answer, if you look.
Mi sensación, perdón que lo pare, Llama no tiene modelo razonador, creo yo, porque se les adelantó DeepSeek. Yo creo que ya por esta fecha Meta quería haber sacado una versión razonadora de sus modelos y DeepSeek sacó algo mejor y se han tenido que quedarse ahí esperando a la siguiente versión que estén cocinando.
If you look at Blackwell, you look at the Blackwell system, and it's now the scaled up NVLink 72. The first thing that we have to do is we have to take this model, and this model is not small. It's, you know, in the case of R1, people think R1 is small, but it's 680 billion parameters. Next generation models could be trillions of parameters. And the way that you solve that problem,
están hablando de DeepSeek sin complejos, lo cual me parece bien.
And this model, and you distribute the workload across the whole system of GPUs. You can use tensor parallel. You can take one layer of the model and run it across multiple GPUs. You could take a slice of the pipeline and call that pipeline parallel and put that on multiple GPUs. You could take different experts and put it across different GPUs. We'll call it expert parallel. The combination of pipeline parallelism and tensor parallelism and expert parallelism, the number of combinations is insane. And depending on the model, depending on the workload, depending on the circumstance, how you configure that computer has to change so that you can get the maximum throughput out of it. You also sometimes optimize for very low latency, sometimes you try to optimize for throughput, and so you have to do some in-flight batching. A lot of different techniques for batching and aggregating work. And so the software, the operating system for these AI factories is insanely complicated. Well, one of the observations, and this is a really terrific thing about having a homogeneous architecture like NVLink 72, is that every single GPU could do all the things that I just described. And we observe that these reasoning models are doing a couple of phases of computing. One of the phases of computing is thinking. When you're thinking, you're not producing a lot of tokens. You're producing tokens that you're maybe consuming yourself. You're thinking. Maybe you're reading. You're digesting information. That information could be a PDF. That information could be a website. You could literally be watching a video, ingesting all of that at super linear rates. And you take all of that information and you then formulate the answer, formulate a plan to answer. And so that digestion of information, context processing, is very flops intensive. On the other hand, during the next phase is called decode. So the first part we call prefill. The next phase of decode requires floating point operations, but it requires an enormous amount of bandwidth. And it's fairly easy to calculate. You know, if you have a model and it's a few trillion parameters, well, it takes a few terabytes per second. Notice I was mentioning 576 terabytes per second. It takes terabytes per second to just pull the model in from HBM memory and to generate literally one token. And the reason it generates one token is because, remember, that these large language models are predicting the next token. That's why they say the next token. It's not predicting every single token, it's predicting the next token. Now we have all kinds of new techniques, speculative decoding, and all kinds of new techniques for doing that faster, but in the final analysis, you're predicting the next token. Okay? And so you...
Ha comentado una cosa que no termino de tenerla tan claro, y es que ha separado como el tema de las IAs que razonan como en dos fases diferentes, la fase de pensar y de ingesta de datos y luego la fase de decodificación, de generación, pero las está como diferenciando como si las necesidades de hardware fueran diferentes, cosa de la que no estoy muy de acuerdo, porque al final es el mismo modelo, o sea, lo único que está cambiando es que estás generando dentro de las tags de thinking, pero el modelo sigue estando decodificando en ambas partes. La única diferencia, si es cierto, si estás haciendo algún tipo de técnica de RAG o si estás llamando a alguna API para hacer búsquedas online, si hay alguna fase de ingesta de datos, eso sí es diferente, puede requerir tiempos diferentes, pero No le veo mucha más diferencia.
ingest, pull in the entire model and the context, we call it a KV cache, and then we produce one token. And then we take that one token, we put it back into our brain, we produce the next token. Every single time we do that, we take trillions of parameters in, we produce one token. Trillions of parameters in, produce another token. Trillions of parameters in, produce another token. And notice that demo, we produced 8,600 tokens. So trillions of bytes of information have been taken into our GPUs and produced one token at a time, which is fundamentally the reason why you want NVLink. NVLink gives us the ability to take all of those GPUs and turn them into one massive GPU, the ultimate scale up. And the second thing is that now that everything is on NVLink, I can disaggregate the prefill from the decode, and I could decide I want to use more GPUs for prefill, less for decode, because I'm thinking a lot. It's agentic. I'm reading a lot of information. I'm doing deep research. Notice during deep research, and earlier I was listening to Michael, and Michael was talking about him doing research, and I do the same thing. And we go off and we write these really long research projects for our AI, and I love doing that because I already paid for it. And I just love making our GPUs work, and nothing gives me more joy. So I write up, and then it goes off and it does all this research, and it went off to like 94 different websites, and it read all this, and I'm reading all this information, and it formulates an answer and writes the report. It's incredible. Okay? During that entire time, prefill is super busy, and it's not really generating that many tokens. On the other hand, when you're chatting with the chatbot, and millions of us are doing the same thing, it is very token generation heavy. It's very decode heavy. Okay? And so, depending on the workload, we might decide to put more GPUs into decode, depending on the workload, put more GPUs into prefill. Well, this dynamic operation is really complicated. So I've just now described pipeline parallel, tensor parallel, expert parallel, in-flight batching, disaggregated inferencing, workload management, and then I've got to take this thing called a KV cache. I've got to route it to the right GPU. I've got to manage it through all the memory hierarchies. That piece of software is insanely complicated. And so today we're announcing the NVIDIA Dynamo.
Está explicando muchas cosas, pero no están presentando tantas, ¿vale?
NVIDIA Dynamo does all that.
Presentado, creo que solo han presentado esto, y la alianza con General Motors.
Whereas in the past, in the way that we ran data centers, our operating system would be something like VMware. And we would orchestrate, and we still do, we're a big user, orchestrate a whole bunch of different enterprise applications running on top of our enterprise IT. But in the future, the application is not enterprise IT, it's agents. And the operating system is not something like VMware, it's something like Dynamo. And this operating system is running on top of not a data center, but on top of an AI factory. Now we call it Dynamo for a good reason. As you know, the dynamo was the first instrument that started the last industrial revolution, the industrial revolution of energy. Water comes in, electricity comes out. It's pretty fantastic. Water comes in, you light it on fire, turn it to steam, and what comes out, this is an invisible thing that's incredibly valuable. It took another 80 years to go to alternating current, but Dynamo is where it all started. Okay, so we decided to call this operating system, this piece of software, insanely complicated software, the NVIDIA Dynamo. It's open source, and we're so happy that so many of our partners are working with us on it. And one of my favorite partners, I just love them so much because of the revolutionary work that they do, and also because Aravin's such a great guy. But Perplexity is a great partner of ours in working through this. Okay, so anyhow, really, really great. Okay, so now we're going to have to wait until we scale up all these infrastructure, but in the meantime, we've done a whole bunch of very in-depth simulation. We have supercomputers doing simulation of our supercomputers, which makes sense. And I'm now going to show you the benefit of everything that I've just said. And remember the factory diagram. On the x-axis is tokens per second throughput, on the y-axis, tokens per second throughput of the factory, and the x-axis, tokens per second of the user experience. And you want super smart AIs, and you want
para que entendamos un poco lo que es, porque no han terminado de...
bunch of it. This is Hopper.
Bueno, no está el diagrama. El Dynamo este que han sacado es una especie de librería, sistema operativo le llaman, pero bueno, sí, me imagino que es un sistema operativo distribuido para las GPUs para hacer inferencia de forma más optimizada, con su pensado para dar flops más rápido, pensado para dar más throughput, que no sabría cómo se traduce. Y que tiene, bueno, pues eso, ¿no? La optimización del KV caché y las típicas cosas que tal. Y eso, no sé si... Bueno, no es tanto una librería, ¿no? Será como algo que estará, que servirá para gestionar los recursos de sus GPUs.
Okay, so this is Hopper, and it can produce for one user, for each user, about 100 tokens per second. This is 8 GPUs, and it's connected with InfiniBand, and I'm normalizing it to tokens per second per megawatt. So it's a 1 megawatt data center, which is not a very large AI factory, but anyhow, 1 megawatt, okay? And so it can produce for each user 100 tokens per second, and it can produce at this level, whatever that happens to be, 100,000 tokens per second for that 1 megawatt data center. Or it can produce about 2.5 million tokens per second, 2.5 million tokens per second for that AI factory if it was super batched up and the customer is willing to wait a very long time. Okay, does that make sense? All right, so nod. All right, because this is where, you know, every GTC, there's the price for entry, you guys know, and it's like you get tortured with math, okay? This is the only at NVIDIA do you get tortured with math. All right, so Hopper, you get 2.5. Now, what's that 2.5 million? How do you translate that? 2.5 million. Remember, ChatGPT is like $10 per million tokens, right? $10 per million tokens. Let's pretend for a second that's. I think the $10 per million tokens is probably down here. Okay, I'd probably say it's down here, but let me pretend it's up there, because 2.5 million, 10, so $25 million per second. Does that make sense? That's how you think through it. Or on the other hand, if it's way down here, then the question is, you know, so it's 100,000, just divide that by 10, okay? $250,000.
Eso me está costando, oye, o sea, seguir un poco todo, pero vale. Nos está mostrando aquí para la arquitectura Hopper, pues lo que sería la misma gráfica que nos enseñaba antes, ¿no? Las dos dimensiones del throughput, o si quitas throughput y añades velocidad para un único usuario, cómo sería el área que esta arquitectura ofrece. Ahora nos enseñará seguramente Blackwell y luego nos enseñará Blackwell con el nuevo sistema Dynamo que nos acaba de presentar, ¿vale?
Factory per second. And then as it was 30 million seconds in a year, and that translates into revenues for that 1 megawatt data center. And so that's your goal. On the one hand, you would like your token rate to be as fast as possible so that you can make really smart AIs. And if you have smart AIs, people pay you more money for it. On the other hand, the smarter the AI, the less you can make in volume. Very sensible trade-off. And this is the curve we're trying to bend. Now, what I'm just showing you right now is the fastest computer in the world, Hopper. It's the computer that revolutionized everything. And so how do we make that better? So the first thing that we do is we come up with Blackwell with NVLink 8.
Vale.
Same Blackwell, that one same compute, and that one compute node with NVLink 8 using FP8. And so Blackwell is just faster, bigger, more transistors, more everything. But we like to do more than that, and so we introduce a new precision. It's not quite as simple as 4-bit floating point, but using 4-bit floating point, we can quantize.
Claro, aquí Hopper, precisión numérica, si no recuerdo mal, FP16, Blackwell FP8, ¿vale? Y si bajamos a FP4, a 4 bits, pues consigues más rendimiento, puedes sacarle más throughput y puedes sacarle más velocidad.
The model use less energy to do the same. And as a result, when you use less energy to do the same, you could do more. Because remember, one big idea is that every single data center in the future will be power limited. Your revenues are power limited. You could figure out what your revenues are going to be based on the power you have to work with. This is no different than, like many other industries. And so we are now a power limited industry. Our revenues will...
Por tener menos floating points, menor precisión, si lo pensamos como cuantización... O sea, bueno, sí, tiene menos precisión, obviamente, pero claro, aquí lo que se está planteando es si podemos de facto entrenar modelos con 4 floating points y que funcionen, ¿no? En teoría hemos visto las bitnets, que son capaces con 2 bits poder entrenar un modelo que es competente. No lo hemos visto a grandes escalas, pero está ahí. Como una evidencia. Entonces, si se consiguen hacer entrenamientos que sean estables a 4 bits, pues tendría sentido, ¿no? Este FP4. Y seguramente NVIDIA ha hecho las pruebas y seguramente haya papers de esto que ahora mismo no pueda citar, pero seguramente se pueda.
Associated with that. Well, based on that, you want to make sure you have the most energy efficient compute architecture you can possibly get. The next, then we scale up with NVLink 72. Does that make sense? Look at the difference between that NVLink 72 FP4, and then because our architecture is so tightly integrated, and now we add Dynamo to it, Dynamo can extend that even further. Are you following me? So Dynamo also helps Hopper, but Dynamo helps Blackwell incredibly. Now, yep.
Entiendo que aquí el truco, el salto entre esta y esta, la única diferencia es el NVLink de 8 a 72, que entiendo que el número es la cantidad de GPUs que puedes conectar. Entonces, al conectar más GPUs consigues más, pero porque el crecimiento de los tokens por segundo partido megavatio no crece de forma lineal, ¿no? Con el número de las GPUs. No sé, tengo que pensar un poco esta gráfica. Me parece súper interesante, pero tengo que pensarla para ver dónde están las trampas, que siempre hay trampas con este tipo de cosillas.
Only at GTC do you get an applause for that. And so now notice what I put, those 2 shiny parts, that's kind of where your max Q is. That's likely where you'll run your factory operations. You're trying to find that balance between maximum throughput and maximum quality of AI. Smartest AI, the most of it. Those two, that XY intercept is really what you're optimizing for. And that's what it looks like if you look underneath those 2 squares. Blackwell is way, way better than Hopper. And remember, this is not ISO chips. This is ISO power. This is ultimate Moore's Law. This is what Moore's Law was always about in the past. And now here we are, 25x in one generation as ISO power. This is not ISO chips, it's not ISO transistors, it's not ISO anything. ISO power, the ultimate limiter. There's only so much energy we can get into a data center. And so within ISO power, Blackwell is 25 times. Now here's that rainbow. That's incredible. That's the fun part. Look, all the different underneath the Pareto, the frontier Pareto, we call it the frontier Pareto, under the frontier Pareto are millions of points we could have configured the data center to do. We could have parallelized and split the work and sharded the work in a whole lot of different ways. And we found the most optimal answer, which is the Pareto, the frontier Pareto, okay, the Pareto frontier. And each one of them because of the color shows you it's a different configuration, which is the reason why this image says very, very clearly you want a programmable architecture that is as homogeneously fungible as possible, because the workload changes so dramatically across the entire frontier. And look, we got on the top, expert parallel 8, batch of 3000, disaggregation off, dynamo off. In the middle, expert parallel 64 with
Está súper súper técnico, ¿vale?
26% is used for context, so dynamo is turned on, 26% context, the other 64% is 74% is
no
not.
súper técnico, pero para hacer una keynote general,
64 on one, expert parallel 4 on the other.
Lo que está diciendo es que aquí, para conseguir un balance entre throughput y la velocidad de generación para un único usuario, tú puedes canjear y puedes decir, quiero tener más throughput y quiero tener menos velocidad para un único usuario. Pues esto lo puedes hacer con una configuración concreta, tocando las múltiples librerías, variables y elementos que tengas en tu data center. Entonces, toda esta frontera se puede sacar configurando cosas, ¿no? En plan, moviéndote entre menos throughput y más velocidad o viceversa. Entonces, cada una de estas serían las configuraciones que han probado para sacarlo.
Down here, all the way to the bottom, you got tensor parallel 16 with expert parallel 4, batch of 2, 1% context. The configuration of the computer is changing across that entire spectrum. And then this is what happens. So this is with input sequence length. This is a kind of a commodity test case. This is a test case that you can benchmark relatively easily. The input is 1,000 tokens. The output is 2,000. Notice earlier, we just showed you a demo where the output is very simply 9,000, right? 8,000, okay? And so obviously this is not representative of just that one chap. Now this one is more representative, and this is what, the goal is to build these next generation computers for next generation workloads. And so here's an example of a reasoning model. And in a reasoning model, Blackwell is 40 times the performance of Hopper, straight up. Pretty amazing. I've said before, somebody actually asked, why would I say that? But I said before that when Blackwell starts shipping in volume, you couldn't give Hoppers away. And this is what I mean. And this makes sense. If you're still looking to buy a Hopper, don't be afraid. It's okay. But I'm the chief revenue destroyer. My sales guys are going, oh no, don't say that. There are circumstances where Hopper is fine.
Está bromeando de que la arquitectura anterior, la Hopper frente a la Blackwell, pues ya como que no tiene tanto sentido comprarla, y está haciendo un poco coñas con eso. Mira que iba a comprar una Hopper aquí para casa.
There are circumstances where you're fine. Not many. If I have to take a swing. And so that's kind of my point. When the technology is moving this fast, and because the workload is so intense, and you're building these things, they're factories. We really like you to invest in the right versions. Okay, just to put it in perspective, this is what a 100 megawatt factory looks like. This is a 100 megawatt factory. You have, based on Hoppers, you have 45,000 dies, 1,400 racks, and it produces 300 million tokens per second. Okay? And then this is what it looks like with Blackwell. You have 86, yeah, I know.
A alguien le ha gustado mucho. Nada, la comparación, ¿no? De si tienes un centro de computación de hoppers, para poder ejecutar, además lo pone aquí abajo, el DeepSeek R1. Les ha gustado el modelo DeepSeek, necesitas unas... A ver, 45.000... Vale, exacto. O sea, lo que está dejando fijo es como la cantidad de megavatios de la AI Factory, ¿no? Si tú tienes una AI Factory de 100 megavatios, eso serían unas 45.000 H100 y por el contrario serían 85.000 porque son más eficientes Blackwells. Y eso te daría un 40... un por 40 de productividad, ¿no? De generación de token o de beneficio por token. No sé exactamente cómo lo están midiendo en este caso.
That doesn't make any sense. Okay, so we're not trying to sell you less. Okay, our sales guys are going, Jensen, you're selling them less. This is better. Okay, and so anyways, the more you buy, the more you save.
Esa frase, la frase de Jensen.
It's even better than that. Now the more you buy, the more you make, you know? And so anyhow, remember, everything is in the context, everything is now in the context of AI factories. And although we talk about the chips, you always start from scale up. We talk about the chips, but you always start from scale up, the full scale up. What can you scale up to the maximum? I want to show you now what an AI factory looks like, but AI factories are so complicated. I just gave you an example of one rack. It has 600,000 parts. You know, it's 3,000 pounds. Now, you've got to take that and connect it with a whole bunch of others. And so we are starting to build what we call the digital twin of every data center. Before you build a data center, you have to build a digital twin. Let's take a look at this. This is just incredibly beautiful.
The world is racing to build state-of-the-art, large-scale AI factories. Bringing up an AI gigafactory is an extraordinary feat of engineering, requiring tens of thousands of workers, from suppliers, architects, contractors, and engineers to build, ship, and assemble nearly 5 billion components and over 200,000 miles of fiber, nearly the distance from the Earth to the Moon. The NVIDIA Omniverse Blueprint for AI Factory Digital Twins enables us to design and optimize these AI factories long before physical construction starts. Here, NVIDIA engineers use the blueprint to plan a 1 gigawatt AI factory, integrating 3D and layout data of the latest NVIDIA DGX SuperPods and advanced power and cooling systems from Vertiv and Schneider Electric, and optimized topology from NVIDIA Air, a framework for simulating network logic, layout, and protocols. This work is traditionally done in silos. The Omniverse Blueprint lets our engineering teams work in parallel and collaboratively, letting us explore various configurations to maximizing TCO and power usage effectiveness. NVIDIA uses Cadence Reality Digital Twin, accelerated by CUDA and Omniverse libraries, to simulate air and liquid cooling systems. And Schneider Electric with ETAP, an application to simulate power block efficiency and reliability. Real-time simulation lets us iterate and run large-scale what-if scenarios in seconds versus hours. We use the digital twin to communicate instructions to the large body of teams and suppliers, reducing execution errors and accelerating time to bring up. And when planning for retrofits or upgrades, we can easily test and simulate cost and downtime, ensuring a future-proof AI factory.
¿Y eso corre Minecraft? La pregunta.
This is the first time anybody who builds data centers says, oh, that's so beautiful. All right, I got a race here because turns out I got a lot to tell you. And so if I go a little too fast, it's not because I don't care about you, it's just I got a lot of information to go through. All right, so first, our roadmap. We're now in full production of Blackwell. Computer companies all over the world are ramping these incredible machines at scale. And I'm just so pleased and so grateful that all of you worked hard transitioning into this new architecture. And now,
Blackwell
in the
Ultra,
second half of this year, we'll easily transition into the upgrade. So we have the Blackwell Ultra, NVLink 72. It's 1.5 times more FLOPS. It's got a new instruction for attention. It's 1.5 times more memory. All that memory is useful for things like KV cache. It's 2 times more bandwidth, okay, for networking bandwidth. And so now that we have the same architecture, we'll just kind of gracefully glide into that, and that's called Blackwell Ultra, okay?
Vale, o sea, pensad que el año pasado presentaron Blackwell. Blackwell ha empezado a comercializarse, creo que ya algunas empresas la recibieron hace unos meses. Hubo problemas de sobrecalentamiento con las Blackwells, creo que seguramente lo estén arreglando toda esta historia. Pero bueno, ya están haciendo el ramp-up para que más empresas y más centros de computación adquieran Blackwells y transicionen de Hopper a Blackwell, ¿no? Que es el mensaje que nos está dando hoy. Y ya ahora están presentando que en la segunda mitad de este año van a empezar a sacar la Blackwell Ultra, que, bueno, pues mejoran esto, ¿no? Más memoria, más bla, 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 más velocidad, etc, etc, etc.
So that's coming second half of this year. Now, there's a reason why this is the only product announcement in any company where everybody's going, yeah. Next. Yeah. And in fact, that's exactly the response I was hoping to get. And here's why. Look, we're building AI factories and AI infrastructure. It's going to take years of planning. This isn't like buying a laptop. This isn't discretionary spend. This is spend that we have to go plan on. And so we have to plan on having, of course, the land and the power, and we have to get our CapEx ready, and we get engineering teams, and we have to lay it out a couple, 2-3 years in advance, which is the reason why I show you our roadmap a couple, 2-3 years in advance, so that we don't surprise you in May. Hi, in another month we're going to go to this incredible new system. I'll show you an example in a second. And so we plan this out in multiple years. The next click, 1 year out, is named after an astronomer,
Rubin.
And her grandkids are here. Her name is Vera Rubin. She discovered dark matter. Okay, yep.
La siguiente arquitectura después de Blackwell.
Vera Rubin is incredible because the CPU is new. It's twice the performance of Grace, more memory, more bandwidth, and yet just a little tiny 50-watt CPU. It's really quite incredible, okay? And Rubin, brand new GPU, CX9, brand new networking smart NIC, NVLink 6, brand new NVLink, brand new memories, HBM4. Basically, everything is brand new except for the chassis. And this way, we could take a whole lot of risk in one direction and not risk a whole bunch of other things related to the infrastructure. And so Vera Rubin, NVLink 144, is the second half of next year. Now, one of the things that I made a mistake on, and so I just need you to make this pivot. We're going to do this one time. Blackwell is really 2 GPUs in one Blackwell chip. We call that one chip a GPU, and that was wrong. And the reason for that is it screws up all the NVLink nomenclature and things like that. So going forward, without going back to Blackwell to fix it, going forward, when I say NVLink 144, it just means that it's connected to 144 GPUs. And each one of those GPUs is a GPU die, and it could be assembled in some package. How it's assembled could change from time to time. Okay?
Vale. Es que el año pasado, cuando presentaron la Blackwell, una de las cosas que hicieron para que los números parecieran incluso más grandes era que en un mismo chip había 2 chips combinados, ¿no? Y que están combinados por el NVLink y no sé, una historia muy rara, y creo que lo acaban de revertir, ¿no? Esa idea, y han dicho que no, que a partir de ahora si son 2, son 2 o algo así, ¿no? Pero bueno, va por ahí los tiros de lo que acaba de comentar.
So each GPU die is a GPU. Each NVLink is connected to the GPU. And so Vera Rubin, NVLink 144. And then this now sets the stage for the second half of the year, the following year, we call Rubin Ultra. Okay, so Vera Rubin Ultra. I know. This where you go, All right, so this is Vera Rubin Ultra, second half of 27. It's NVLink 576, extreme scale up. Each rack is 600 kilowatts, 2.5 million parts, okay? And obviously a whole lot of GPUs. And everything is X factored more. So 14 times more flops, 15 exaflops. Instead of 1 exaflop, as I mentioned earlier, is now 15 exaflops, scaled up exaflops, okay? And it's 4.6 petabytes, so 4,600 terabytes per second scale up bandwidth. I don't mean aggregate, I mean scale up bandwidth. And of course, lots of brand new NVLink switch and CX9, okay? And so notice 16 sites, 4 GPUs in one package, extremely large NVLink. Now just put that in perspective. This is what it looks like, okay?
Yes.
Now this is going to be fun. So you are just literally ramping up Grace Blackwell at the moment, and I don't mean to make it look like a laptop, but here we go. Okay, so this is what Grace Blackwell looks like, and this is what Rubin looks like. ISO dimension. And so this is another way of saying, before you scale out, you have to scale up. Does that make sense? Before you scale up, scale out, you scale up. And then after that, you scale out with amazing technology that I'll show you in just a second. All right, so first you scale up, and then now that gives you a sense of the pace at which we're moving. This is the amount of scale up flops. This is scale up flops. Hopper is 1x, Blackwell is 68x, Rubin is 900x. Scale up flops. And then if I turn it into essentially your TCO, which is power on top, power per, and the underneath is the area underneath the curve that I was talking to you about, the square underneath the curve, which is basically flops times bandwidth, okay? So the way you think about a very easy gut check on whether your AI factories are making progress is watts divided by those numbers. And you can see that Rubin is going to drive the cost down tremendously. Okay, so that's very quickly NVIDIA's roadmap.
Bueno, pues ya tenemos spoiler del GTC 2026, GTC 2027.
Once a year like clock ticks. Once a year. Okay, how do we scale up? Well, we were preparing to scale out. That was scale up, was NVLink. Our scale out network is InfiniBand and Spectrum-X. Most were quite surprised that we came into the Ethernet world. And the reason why we decided to do Ethernet is if we could help Ethernet become like InfiniBand, have the qualities of InfiniBand, then the network itself would be a lot easier for everybody to use and manage. And so we decided to invest in Spectrum. We call it Spectrum-X, and we brought to it the properties of congestion control and very low latency and a mountain of software that's part of our computing fabric. And as a result, we made Spectrum-X incredibly high performant. We scaled up the largest single GPU cluster ever as one giant cluster with Spectrum-X, right? And that was Colossus. And so there are many other examples of it. Spectrum-X is unquestionably a huge home run for us. One of the areas that I'm very excited about is the largest enterprise networking company to take Spectrum-X and integrate it into their product line so that they could help the world's enterprises become AI companies. We're at 100,000 with CX7. Now CX8's coming, CX9's coming, and during Rubin's time frame, we would like to scale out the number of GPUs to many hundreds of thousands. Now, the challenge with scaling out GPUs to many hundreds of thousands is the connection of the scale out. This connection on scale up is copper. We should use copper as far as we can, and that's, call it a meter or two. And that's incredibly good connectivity, very high reliability, very good energy efficiency, very low cost. And so we use copper as much as we can on scale up, but on scale out, where the data centers are now the size of the stadium, we're going to need something much long distance running. And that's just where silicon photonics comes in. The challenge of silicon photonics has been that the transceivers consume a lot of energy. To go from electrical to photonic has to go through a SerDes, go through a transceiver and a SerDes, several SerDes. And so each one of these, am I alone? Is anybody? What happened to my networking guys? Can I have this up here? Yeah, let's bring it up so I can show people what I'm talking about. Okay, so first of all, we're announcing NVIDIA's first co-packaged option, silicon photonic system. It is the world's first 1.6 terabit per second CPO. It is based on a technology called micro-ring resonator modulator, and it is completely built with this incredible process technology at TSMC that we've been working with for some time. And we partnered with just a giant ecosystem of technology providers to invent what I'm about to show you. This is really crazy technology, crazy technology. Now, the reason why we decided to invest in MRM is so that we could prepare ourselves using MRM's incredible density and power, better density and power compared to Mach Zehnder, which is used for telecommunications when you drive from one data center to another data center in telecommunications, or even in the transceivers that we use Mach Zehnder, because the density requirement is not very high.
¿Pero son chips fotónicos o es para la comunicación entre diferentes centros de datos que vaya rápido? Yo creo que es lo segundo, ¿no? Es para poder... Estamos hablando ya de centros de computación que son tan grandes que van a ser varias instalaciones, a lo mejor en diferentes localizaciones conectadas, y que el envío de información será así, ¿no? Entiendo. Madre mía, Jensen.
Oh, wow. Thank you.
Qué bueno es el tío, ¿eh?
Oh, mother of God.
Tampoco hace falta.
Okay. This is where you got to turn reasoning on.
Uy.
It's not as easy as you think. These are squirrely little things. All right, so this one right here, this is 30 watts, just so keep you remember, this is 30 watts. And if you buy it in high volume, it's $1,000. This is a plug. On this side is electrical. On this side is optical. Okay, so optics come in through the yellow. You plug this into a switch. It's electrical on this side. There's transceivers, lasers, and it's a technology called Mach Zehnder, and incredible. And so we use this to go from the GPU to the switch to the next switch, and then the next switch down, and the next switch down to the GPU, for example. And so each one of these, if we had 100,000 GPUs, we would have 100,000 of this side, and then another, 100,000, which connects the switch to the switch, and then on the other side, I'll attribute that to the other NIC. If we had 250,000, we'll add another layer of switches, and so each GPU, every GPU, 250,000, every GPU would have 6 transceivers. Every GPU would have 6 of these plugs, and these 6 plugs would add 180 watts per GPU, 180 watts per GPU, and $6,000 per GPU, okay? And so the question is, how do we scale up now to millions of GPUs? Because if we had 1 million GPUs, multiplied by 6, right, it would be 6 million transceivers times 30 watts, 180 megawatts of transceivers They didn't do any math, they just moved signals around. And so the question is, how could we afford, and as I mentioned earlier, energy is our most important commodity. Everything is related ultimately to energy. So this is going to limit our revenues, our customers' revenues, by subtracting out 180 megawatts of power. And so this is the amazing thing that we did. We invented the world's first MRM micromirror, and this is what it looks like. There's a little waveguide, you see that on that waveguide, goes to a ring. That ring resonates, and it controls the amount of reflectivity of the waveguide as it goes around, and limits and modulates the energy, the amount of light that goes through. And it shuts it off by absorbing it or pass it on. Okay, it turns the light, this direct continuous laser beam, into ones and zeros. And that's the miracle. And that technology is then, that photonic IC is stacked with the electronic IC, which is then stacked with a whole bunch of micro lenses, which is stacked with this thing called fiber array. These things are all manufactured using this technology at TSMC called, they call it COUPE, and packaged using a 3D CoWoS technology, working with all of these technology providers, a whole bunch of them, the names I just showed you earlier, and it turns it into this incredible machine. So let's take a look at the video of it.
Vale. No he terminado de entender si lo que están haciendo es solucionar el tema de los cables. Esto me lo tendré que repasar de nuevo. Una máquina para hacer espaguetis.
Just a technology marvel. And they turn into these switches. Our InfiniBand switch, the silicon is working fantastically. Second half of this year, we will ship the silicon photonics switch in the second half of this year. In the second half of next year, we'll ship the Spectrum X. Because of the MRM choice, because of the incredible technology risks that over the last 5 years that we did, and filed hundreds of patents, and we've licensed it to our partners so that we can all build them. Now, we're in a position to put...
Estoy leyendo que se ha caído el streaming oficial.
No transceivers, fiber, direct fiber into our switches with a radix of 512. This is the 512 ports. This would just simply not be possible any other way. And so this now set us up to be able to scale up to these multi-100,000 GPUs and multi-million GPUs. And the benefit, just so you imagine this, it's incredible. In a data center, we could save tens of megawatts. Let's say 10 megawatts, well, let's say 60 megawatts, 6 megawatts is 10 Rubin Ultra racks. 6 megawatts is 10 Rubin Ultra racks, right? And 60, that's a lot. 100 Rubin Ultra racks of power that we can now deploy into Rubins. All right, so this is our roadmap once a year.
Ojo, Feynman, la siguiente.
Every 2 years, a new product line every single year, X factors up. and we try to take silicon risk or networking risk or system chassis risk in pieces so that we can move the industry forward as we pursue these incredible technology. Vera Rubin, and I really appreciate the grandkids for being here. This is our opportunity to recognize her and to honor her for the incredible work that she did. Our next generation will be named after Feynman. Okay, NVIDIA's roadmap. Let me talk to you about enterprise computing. This is really important. In order for us to bring AI to the world's enterprise, first we have to go to a different part of NVIDIA. The beauty of Gaussian splats. Okay, in order for us to take AI to enterprise, take a step back for a second and remind yourself this. Remember, AI and machine learning has reinvented the entire computing stack. The processor is different, the operating system is different, the applications on top are different. The way the applications are different, the way you orchestrate it are different, and the way you run them are different. Let me give you one example. The way you access data will be fundamentally different than the past. Instead of retrieving precisely the data that you want and you read it to try to understand it, in the future, we will do what we do with Perplexity. Instead of doing retrieval that way, I'll just ask Perplexity what I want. Ask it a question, and it will tell you the answer. This is the way enterprise IT will work in the future as well. We'll have AI agents, which are part of our digital workforce. There's 1 billion knowledge workers in the world. There are probably going to be 10 billion digital workers working with us side by side. 100% of software engineers in the future, there are 30 million of them around the world, 100% of them are going to be AI assisted. I'm certain of that. 100% of NVIDIA software engineers will be AI assisted by the end of this year.
Es diferente esa frase a la que dijo en el pasado,
How they run,
sobre los desarrolladores.
what enterprises run and how we run it will be fundamentally different. And so we need a new line of computers. And this...
Uy, está en la parte que se ha perdido del streaming. Vaya truco de magia, Joe. Pop.
This is what a PC should look like. 20 petaflops. Unbelievable. 72 CPU cores, chip-to-chip interface, HBM memory, and just in case, some PCI Express slots for your GeForce. Okay, so this is called DGX Station. DGX Spark and DGX Station are going to be available by all of the OEMs. HP, Dell, Lenovo, Asus. It's going to be manufactured for data scientists and researchers all over the world. This is the computer of the age of AI. This is what computers should look like. And this is what computers will run in the future. And we have a whole lineup for enterprise now.
Esto es el otro negocio de NVIDIA al final, ¿no? Las workstation, al final sí sabemos que la IA, parte de la IA se va a consumir en la nube, ok, pero también otra parte se va a consumir en local. Si las compañías van a tener a sus trabajadores trabajando con modelos en local, pues vas a tener que necesitar a lo mejor o una cloud interna o una workstation para ejecutar los modelos en local, ¿no? Y ahí NVIDIA pues también tiene su propia línea de negocio, ¿cómo no?
Little tiny one to workstation ones, the server ones to supercomputer ones, and these will be available by all of our partners. We will also revolutionize the rest of the computing stack. Remember, computing has 3 pillars. There's computing, you're looking at it. There's networking, as I mentioned earlier, Spectrum X going to the world's enterprise, an AI network. And then third is storage. Storage has to be completely reinvented. Rather than a retrieval-based storage system, it's going to be a semantics-based retrieval system, a semantics-based storage system. And so the storage system has to be continuously embedding information in the background, taking raw data, embedding it into knowledge, and then later when you access it, you don't retrieve it, you just talk to it. You ask it questions, you give it problems. And one of the examples, I wish we had a video of it, but Aaron at Box even put one up in the cloud, worked with us to put it up in the cloud. And it's basically, a super smart storage system. And in the future, you're going to have something like that in every single enterprise. That is the enterprise storage of the future. And we're working with the entire storage industry, really fantastic partners, DDN and Dell and HP Enterprise and Hitachi and IBM and NetApp and Nutanix and Pure Storage and VAST and Weka. Basically, the entire world storage industry will be offering this stack. For the very first time, your storage system will be GPU accelerated.
Tío, flipad que la presentación son 2 horas y vamos para un poco más porque se va a hablar de robótica.
And so Michael thought I didn't have enough slides, so he said, Jensen, just in case you don't have enough slides.
Y es el tío hablando todo el rato. O sea, no es como una presentación donde venga y ahora que suba a tal persona a hablar, ahora que venga a tal persona no sé qué, no. Todo el rato hablando, menos un par de vídeos. Tela, tiene mérito.
In one single slide, he's explaining that Dell is going to be offering a whole line of NVIDIA enterprise IT AI infrastructure systems and all the software that runs on top of it. Okay, so you can see that we're in the process of revolutionizing the world's enterprise. We're also announcing today this incredible model that everybody can run. And so I showed you earlier R1, a reasoning model. I showed you versus Llama 3, a non-reasoning model. And obviously R1 is much smarter, but we can do it even better than that. And we can make it possible to be enterprise ready for any company. And it's now completely open source. It's part of our system we call NIMS. And you can download it, you can run it anywhere, you can run it on DGX Spark, you can run it on DGX Station, you can run it on any of the servers that the OEMs make. You can run it in the cloud, you can integrate it into any of your agentic AI frameworks. And we're working with companies all over the world, and I'm going to flip through these, so watch very carefully. I've got some...
Llama Nemotron Super. Entiendo que es una versión... a ver, llama Nemotron Super. NVIDIA llama Nemotron Super. ¿Qué cojones es esto? Tokens, Vale.
Great partners in the audience want to recognize Accenture, Julie Sweet and her team are building their AI factory and their AI framework. Amdocs, the world's largest telecommunications software company. AT&T, John Stankey and his team building an AT&T AI system, agentic system. Larry Fink and BlackRock team building theirs. Annie Rude, in the future, not only will we hire ASIC designers, we're going to hire a whole bunch of digital
ASIC
se
llama Llama, que está basado en Llama,
that
obviamente.
will help us design our chips. And so Cadence is building their AI framework, and as you can see, in every single one of them, there's NVIDIA models, NVIDIA NIMs, NVIDIA libraries integrated throughout.
So pero es un modelo razonador, es que no lo he entendido.
In the cloud, any cloud. Capital One, one of the most advanced financial services. Deloitte, Jason and his team, EY, Janet and his team, NASDAQ, and Adina and her team, integrating NVIDIA technology into their AI frameworks, and then Christian and his team at SAP, Bill McDermott and his team at ServiceNow. That was pretty good, huh? First, this is one of those keynotes where the first slide took 30 minutes, and then all the other slides took 30 minutes, all right? So next, let's go somewhere else. Let's go talk about robotics, shall we?
Venga, sí. Venga, Jensen, que
let's talk about robots. Well, the time has come for robots. Robots have the benefit of being able to interact with the physical world and do things that otherwise digital information cannot. We know very clearly that the world has severe shortage of human laborers, human workers. By the end of this decade, the world is going to be at least 50 million workers short. We'd be more than delighted to pay them each $50,000 to come to work. We're probably going to have to pay robots $50,000 a year to come to work. And so this is going to be a very, very large industry. There are all kinds of robotic systems. Your infrastructure will be robotic. Billions of cameras in warehouses and factories, 10, 20 million factories around the world. Every car is already a robot, as I mentioned earlier, and then now we're building general robots. Let me show you how we're doing that.
Everything that moves will be autonomous. Physical AI will embody robots of every kind
Iba a decir una
in
tontería,
every
pero
industry.
me la callo.
3 computers built by NVIDIA enable a continuous loop of robot AI simulation, training, testing, and real-world experience. Training robots requires huge volumes of data. Internet-scale data provides common sense and reasoning, but robots need action and control data, which is expensive to capture. With blueprints built on NVIDIA Omniverse and Cosmos, developers can generate massive amounts of diverse, synthetic data for training robot policies. First, in Omniverse, developers aggregate real-world sensor or demonstration data according to their different domains, robots, and tasks. Then use Omniverse to condition Cosmos, multiplying the original captures into large volumes of photoreal, diverse data. Developers use Isaac Lab to post-train the robot policies with the augmented dataset.
Qué guapo. Ese es Atlas.
And let the robots learn new skills by cloning behaviors through imitation learning, or through trial and error, with reinforcement learning AI feedback. Practicing in a lab is different than the real world. New policies need to be field tested. Developers use Omniverse for software.
Atlas se mueve muy
and
raro.
Hardware in the loop testing.
Debería ser ilegal cómo se
simulating
mueve.
The policies in a digital twin with real-world environmental dynamics, with domain randomization, physics feedback, and high-fidelity sensor simulation. Real-world operations require multiple robots to work together. Mega, an Omniverse blueprint, lets developers test fleets of post-trained policies at scale. Here, Foxconn tests heterogeneous robots in a virtual NVIDIA Blackwell production facility. As the robot brains execute their missions, they perceive the results of their actions through sensor simulation, then plan their next action. Mega lets developers test many robot policies, enabling the robots to work as a system, whether for spatial reasoning, navigation, mobility, or dexterity. Amazing things are born in simulation. Today, we're introducing NVIDIA Isaac GR00T N1. GR00T N1 is a generalist foundation model for humanoid robots.
Le ponen casco
It's
al robot.
built on the foundations of synthetic data generation and learning in simulation. GR00T N1 features a dual system architecture for thinking fast and slow, inspired by principles of human cognitive processing.
Esta arquitectura es similar a lo que presentó Helix. Lo que presentó Figure, que se llamaba Helix, que es súper interesante, lo quiero tratar en el canal, en alguno de los dos canales, que es básicamente un modelo que te permite pensar rápido y pensar lento para poder adaptarse, para poder percibir con visión y poder ejecutar acciones que se adapten a varios tipos de problemas. Entonces, lo que ha conseguido Figure, por ejemplo, es que los robots puedan tener una destreza y manipular objetos, incluso que no hayan visto previamente en su entrenamiento, que puedan generalizar a cualquier tipo de objeto y tener cierta destreza, ¿no? Y se parece mucho a esto, a esta arquitectura que están presentando aquí, con la misma idea de System 1 y System 2, ¿no?
Slow, inspired by principles of human cognitive processing. The slow thinking system lets the robot perceive and reason about its environment and instructions, and plan the right actions to take. The fast thinking system translates the plan into precise and continuous robot actions. GR00T N1's generalization lets robots manipulate common objects with ease and execute multi-step sequences collaboratively. And with this entire pipeline of synthetic data generation and robot learning, humanoid robot developers can post-train GR00T N1 across multiple embodiments and tasks across many environments. Around the world, in every industry, developers are using NVIDIA's 3 computers to build the next generation of embodied AI.
Curioso que no aparecen ejemplos de Unitree, por ejemplo, que para mí es de robótica la que mejor movilidad está consiguiendo.
Physical AI and robotics are moving so fast. Everybody pay attention to this space. This could very well likely be the largest industry of all. At its core, we have the same challenges. As I mentioned before, there are three that we focus on. They are rather systematic. One, how do you solve the data problem? How, where do you create the data necessary to train the AI? Two, what's the model architecture? And then three, what's the scaling laws? How can we scale either the data, the compute, or both, so that we can make AIs smarter and smarter and smarter? How do we scale? And those fundamental problems exist in robotics as well. In robotics, we created a system called Omniverse. It's our operating system for physical AIs. You've heard me talk about Omniverse for a long time. We added two technologies to it. Today I'm going to show you two things. One of them is so that we could scale AI with generative capabilities. A generative model that understands the physical world. We call it Cosmos. Using Omniverse to condition Cosmos, and using Cosmos to generate an infinite number of environments allows us to create data that is grounded, controlled by us, and yet be systematically infinite at the same time. Okay, so you see Omniverse, we use candy colors to give you an example of us controlling the robot in the scenario perfectly, and yet Cosmos can create all these virtual environments. The second thing, just as we were talking about earlier, one of the incredible scaling capabilities of language models today is reinforcement learning, verifiable rewards. The question is, what's the verifiable rewards in robotics? And as we know very well, it's the laws of physics.
Claro.
Verifiable physics rewards. And so we need an incredible physics engine. Well, most physics engines have been designed for a variety of reasons. They could be designed because we want to use it for large machineries, or maybe we design it for virtual worlds, video games and such. But we need a physics engine that is designed for very fine-grained, rigid and soft bodies, designed for being able to train tactile feedback and fine motor skills and actuator controls. We need it to be GPU accelerated so that these virtual worlds could live in super linear time, super real time, and train these AI models incredibly fast. And we need it to be integrated harmoniously into a framework that is used by roboticists all over the world, mucho. And so today we're announcing something really, really special. It is a partnership of three companies: DeepMind,
Okay.
Disney Research, and NVIDIA, and we call it Newton.
Ok. Ojo.
Let's take a look at Newton.
Vale, es un simulador para IA. Es como una evolución del Muyoko. Curioso. Estos robots son la hostia, ¿eh? Yo quiero, desde que lo comercialicen, yo quiero 20 en mi casa. Haciendo ruiditos todo el día.
Thank you. All right, let's start that over, shall we?
Ah, vale, qué susto.
Let's not ruin it for them. Hang on a second. Somebody talk to me. I need feedback. What happened?
Oh, se trabó.
I just need a human to talk to. Come on, that's a good joke. Give me a human to talk to. Janine, I know it's not your fault, but talk to me. We just got 2 minutes left.
I'm right here. They're re-racking
They're re-racking
it.
it? I don't even know what that means. Okay.
Vale, se les paró el vídeo. Hola. Otra vez lo sacan este año. ¿Qué les gusta, sacar estos robots?
Tell me that wasn't amazing. Hey, Blue. How are you doing? How do you like your new physics engine? You like it, huh? Yeah, I bet. I know. Tactile feedback, rigid body, soft body, simulation.
Bueno, lo que han presentado es como una especie de nuevo simulador, entiendo, sobre mucho, que tiene capacidades de simulación de físicas, de soft body, hard bodies, para hacer simulaciones más realistas, para entrenar la IA.
Look how smart you are. Yes, you're smart. Okay. All right. Hey, Blue, listen. How about let's take them home? Let's finish this keynote. It's lunchtime. Are you ready? Let's finish it up. We have another announcement. You're good. You're good. Just stand right here. Stand right here. Stand right here. All right, good. Right there. That's good. All right, stand.
Qué maravilla, ¿eh? Que los parques de atracciones de Disney se van a llenar de estos robots.
We have another amazing news. I told you the progress of our robotics has been making enormous progress. And today we're announcing that Groot N1 is open sourced.
Ok, wow, bien. Groot, lo que hemos comentado antes, lo que la empresa Figure llama Helix, que es este modelo capaz de generalizar la destreza de los robots y tal, lo acaban de hacer ellos, lo acaban de hacer open source, lo cual es muy buena noticia.
I want to thank all of you to come let's wrap up. I want to thank all of you for coming to GTC. We talked about several things. One, Blackwell is in full production, and the ramp is incredible. Customer demand is incredible, and for good reason.
Ahora os comento una cosa que han dejado ahí en el aire y no han terminado de concretar. Ahora lo comentamos.
So much greater as a result of reasoning AI and the training of reasoning AI systems and agentic systems. Second, Blackwell NVLink 72 with Dynamo is 40 times the performance, AI factory performance of Hopper. And inference is going to be one of the most important workloads in the next decade as we scale out AI. Third, we have an annual rhythm of roadmaps that has been laid out for you so that you could plan your AI infrastructure. And then we have three AI infrastructures we're building. AI infrastructure for the cloud, AI infrastructure for enterprise, and AI infrastructure for robots. We have one more treat for you. Play it.
Obviamente, claro, el robot está teleoperado y todo esto, pero bueno, una vez tienes programadas las rutinas de movimiento y lo has entrenado con aprendizaje por refuerzo para moverse y adaptarse por el mundo, puedes tenerlo de forma autónoma un juguete como este. Posiblemente no se adapte a todas las situaciones, pero... Pues se recalifica el terreno y montamos un hotelito en esa...
Thank you, everybody. Thank you for all the partners that made this video possible. Thank you, everybody that made this video possible. Have a great GTC. Thank you.
Bueno, lo tenemos.
Hey, Blue. Let's go home. Good job.
Ojalá se caiga el robot ahora. Bueno, lo tenemos, chicos. Voy a hacer un comentario final porque hay una cosa que han dejado ahí en el aire que me ha dado mucha rabia, pero que me parece interesante y me ha dado rabia porque es una idea, es una reflexión que hice hace unas semanas, que me di cuenta y que he incluido dentro del vídeo que voy a publicar esta semana en este canal. Por fin vamos a sacar vídeo aquí en .csv, no solamente en .csv Lab, y que tiene que ver con esta diapositiva de aquí, que me estaba pareciendo súper interesante, pero que la han dejado a medias seguramente por falta de tiempo, ¿vale? Fijaos que estaba diciendo Jensen una cosa muy chula, y era haciendo una equivalencia entre el paradigma que nos había contado al principio de las escalas, el preentrenamiento, el postentrenamiento y el test time compute, el test time scaling, lo estaba trayendo al mundo de la robótica y todo esto. Y fijaos que nos han hablado del pre-training y el post-training, pero no del test time scaling. Y esta es una idea súper chula que tiene que ver con el vídeo que vamos a sacar esta semana, como digo, que es un vídeo sobre generación de vídeo y sobre las físicas de los generadores de vídeo, ¿vale? Entonces, la reflexión que hice hace no mucho es que el año pasado, si recordáis, hablando de modelos del mundo y hablando de cómo la IA de generación de vídeo puede ayudar, por ejemplo, en conducción autónoma. Tú tienes un vehículo que cuando se está conduciendo puede planificar a futuro, si tiene una buena capacidad de generación de vídeo. Tú puedes decir, vale, si estoy en esta situación, tengo un coche delante y el semáforo se pone en verde, simula, genera qué podría pasar, ¿no? Y entonces un generador de vídeo podría decir, pues puede pasar esto, y entonces ahí la IA estaría planificando, podría generar como una planificación de, vale, si esto es lo que va a ocurrir, hago esta cosa. Y el otro día conecté esta idea con la idea del test time compute, ¿vale? Nosotros tenemos modelos de razonamiento que generan tokens para planificar, para pensar, para razonar antes de generar una respuesta al usuario. Y esta idea de tener un modelo de generación de vídeo que planifique cómo va a evolucionar la física del mundo real sería el equivalente en el panorama de la robótica y del test time compute, pero en este caso aplicado a un entorno visual, ¿no? Y estaba a punto de decirlo Jensen, pero no lo ha dicho, se ha quedado en este segundo nivel. Me ha parecido súper interesante, la verdad, la asociación de ideas que ha hecho, ¿no? El pre-training es generación de datos sintéticos, para eso ellos tienen Omniverse y pueden generar entornos simulados con toda la variación aleatoria de dominio, que es como se hace, modificando todos los elementos de luz y texturas y todas estas cosas. Luego el siguiente nivel, el post-training, él ha hablado de tener simuladores que sirvan para validar con la física del mundo real, es decir, para hacer simulaciones donde se simulen las colisiones, los rigid body, los soft bodies, y que eso sirva como validador para poder hacer entrenamientos en simulación. Y luego ese tercer nivel que no ha comentado, que lo han dejado ahí por falta de tiempo. No sé, me ha parecido muy interesante esta asociación y en general me ha parecido un GTC con pocos anuncios, ciertamente, pero interesante, ¿no? Siempre mola mucho escuchar a un CEO de una compañía influyente dentro de todo lo que está pasando en el mundo de la IA, además entrando a aspectos un poquito más técnicos de lo que suelen ser otras presentaciones de otras empresas. Así que en ese sentido, bastante contento. Quiero saber vuestras impresiones, si os ha gustado, si os ha interesado. Sin City pregunta, ¿eso es lo que se llamaba World Models? Sí, está muy relacionado con World Models. Sí. O sea, la idea está ahí y los World Models bien utilizados podrían permitir justamente esto, ¿no? El plantear un test time compute con cadenas de razonamiento visuales donde simulas, ¿no? Donde estás simulando lo que el robot podría, lo que todas las dinámicas de ese mundo podrían evolucionar para decir, vale, pues hago una planificación. Esta es la keynote principal del GTC. Recordad que tenéis un montón de sesiones. Desde ayer hasta el jueves tenéis sesiones gratuitas que podéis registraros y que registrándoos tenéis también disponible el sorteo, donde estamos sorteando unas 50-90 y donde estamos sorteando otros grandes premios. Simplemente para participar en el sorteo, recordad, tenéis toda la información en el hilo de Twitter que está puesto abajo en la descripción de este vídeo, pero los pasos son sencillos. Os registráis con el enlace de la oferta que estamos haciendo. Tenéis hasta el jueves para el registro antes de que acabe el GTC, así que daos prisa. Tenéis que asistir a una de las sesiones, no vale la keynote que hemos visto hoy, tiene que ser alguna de las otras sesiones. Y tercero, rellenar el formulario que está puesto en el hilo de Twitter contando pues a qué sesión habéis asistido y contando un poco de la información que os pone en el formulario. Con estas tres cosas participáis en el sorteo y con mucha suerte os lleváis unas 50-90 para casa, pues para calentaros en estos inviernos tan fríos y lluviosos que estamos teniendo. Así que chicos, chicas, muchas gracias por pasaros por este streaming. Tenemos mucho más contenido por venir aquí al canal. Ya he hecho el spoiler del vídeo que se viene esta semana aquí en .csv. Estoy publicando mucho contenido en el canal secundario, en .csv Lab, donde cubrimos toda la actualidad. Ahí hemos subido vídeo hace poquito sobre, la semana pasada, un tutorial sobre diferentes IAs open source para generar música, para generar vídeo con One, modelo open source espectacular de generación de vídeo, y el modelo QWQ32B de la empresa Quen. Publiqué vídeo probando Manus, la IA agéntica, que también es espectacular cómo funciona. Y recientemente, ayer, publiqué otro vídeo, o sea, estamos publicando un montón de contenido, no os podréis quejar, sobre el nuevo editor de imágenes de Gemini 2.0 Flash, que también es una tecnología bastante interesante que al menos tenéis que conocer y que además podéis probar de forma gratuita. Así que suscribíos a este canal, suscribíos al .csv Lab, seguidme para más inteligencia artificial. Y chicos, chicas, muchas gracias por verme. Nos vemos en el próximo streaming. Chao, chao.